Long before formal markets or written contracts, human societies were already connected through exchange. Trade did not emerge suddenly or uniformly, but as a gradual response to imbalance. Some communities produced more food than they could consume, while others had access to materials unavailable elsewhere. Exchange became a way to smooth these differences without central coordination. Over time, repeated acts of exchange created patterns that extended beyond individual transactions. These patterns would become the earliest foundations of global trade systems. The earliest exchanges were embedded in daily survival rather than abstract economic calculation. Surplus grain, stone tools, animal hides, and crafted objects moved between groups through barter or gifting. These exchanges often carried social meaning alongside material value. Trust, reputation, and obligation mattered as much as the goods themselves. The absence of formal pricing did not imply randomness, but rather a different logic of value. What mattered was continuity, not optimization. Geography played a decisive role in shaping these early networks. Rivers provided natural corridors that reduced the effort required to move goods. Coastlines enabled travel between distant settlements using relatively simple watercraft. Mountain ranges, deserts, and dense forests limited movement and increased isolation. The cost of transport, measured in time and risk, determined how far exchange could realistically extend. Communities adapted their exchange patterns to these physical constraints. The mechanism behind early trade was simple but powerful. When transport costs were low enough, exchange became viable beyond immediate neighbors. Lower friction allowed goods to travel farther while retaining usefulness. This encouraged specialization as groups focused on producing what their environment supported best. Over time, specialization increased surplus, which further reinforced exchange. A feedback loop emerged between production and trade. Archaeological evidence suggests that such networks formed surprisingly early. By around 7000 BCE, obsidian from Anatolian sources appeared in settlements hundreds of kilometers away. At the time, obsidian was valued for its sharpness and reliability in tool-making. Excavation records show consistent material composition across distant sites. This indicates not random movement, but structured exchange. Even without written records, material traces reveal durable trade connections. These early networks were not isolated events, but recurring structures. Exchange routes were maintained because they served ongoing needs. Knowledge about paths, seasons, and intermediaries accumulated over generations. The routes themselves became assets, even if no single group controlled them. Trade was already shaping spatial relationships between communities. The architecture of exchange was beginning to take form. As exchange networks expanded, they began to influence settlement patterns. Communities located along rivers or crossroads gained strategic importance. These locations attracted traders, artisans, and intermediaries. Over time, they developed into hubs where goods, information, and people converged. The concentration of activity reinforced their role within broader networks. Geography and exchange became mutually reinforcing forces. The process by which hubs emerged followed a consistent pattern. Initial advantage came from location rather than size or power.
Once exchange increased, these locations accumulated surplus and skills. This attracted further activity, deepening their role as intermediaries. The reason this persisted was simple. Central points reduced overall transport costs for many participants at once. Efficiency emerged without deliberate design. Historical evidence supports this gradual consolidation. During the Neolithic period, settlements along the Tigris and Euphrates rivers show higher artifact diversity than more isolated sites. At the time, these river systems connected agricultural regions with different production strengths. Records from later periods suggest that these patterns endured for centuries. Early hubs often became the foundation for later urban centers. Trade preceded cities, not the other way around. Exchange also encouraged the development of standardized practices. Repeated transactions required shared expectations about quantity and quality. Early forms of measurement emerged, often based on natural units like weight or volume. While not universal, these conventions reduced friction. They made exchange more predictable across groups. Predictability increased participation. The mechanism here was cumulative. Each successful exchange reduced uncertainty for the next one. Over time, norms hardened into informal rules. These rules governed who could trade, what could be exchanged, and under what conditions. Social enforcement replaced formal authority. Reputation became a form of capital. According to archaeological studies conducted by the British Museum, prestige goods often traveled farther than utilitarian items. Objects like shells, beads, and decorative stones appear in elite burials far from their source. These items carried symbolic value beyond their practical use. Their movement indicates long-distance connections maintained for social as well as material reasons. Exchange networks thus served multiple functions simultaneously. By reinforcing both economic and social ties, early trade networks became resilient. They adapted to local disruptions without collapsing entirely. If one route failed, alternatives emerged over time. The system was decentralized but durable. This resilience would become a defining feature of later global trade architectures. Over time, exchange began to separate from purely social contexts. Specialized roles emerged within trading networks. Some individuals focused primarily on moving goods rather than producing them. These intermediaries reduced the burden on producers. They also accumulated knowledge about routes, demand, and timing. Trade began to resemble a distinct activity. The process of intermediation changed how exchange operated. Intermediaries connected groups that might never meet directly. This expanded the reach of trade beyond immediate cultural boundaries. It also introduced layers between production and consumption. Goods passed through multiple hands, each adding value through transport or information. Complexity increased without central planning. Historical records from Mesopotamia illustrate this transition. By around 3000 BCE, clay tablets recorded transactions involving third-party traders. At the time, these records documented quantities, destinations, and obligations. The presence of written accounting suggests repeated, structured exchange. Trade was no longer incidental, it was becoming institutionalized. The reason intermediaries persisted was efficiency. Producers could focus on production while traders managed risk and movement. This division of labor reduced overall costs. It also allowed trade to scale. Larger volumes could move over longer distances. The system became more interconnected. Maritime trade further accelerated this process. Maritime navigation allowed bulk goods to move with relatively low energy expenditure. Early seafaring cultures in the Mediterranean exploited this advantage. Goods like olive oil, wine, and metals traveled between islands and mainland ports. These routes connected diverse ecological zones. Maritime exchange expanded both scale and scope. According to research published by the University of Cambridge, early Mediterranean trade networks exhibited stable route patterns over several centuries. Shipwreck evidence shows consistent cargo compositions. This suggests regularized trade rather than sporadic voyages. Stability reduced risk and encouraged investment in vessels and ports. Infrastructure followed exchange. As routes stabilized, they became embedded in political and cultural systems. Control over key passages conferred influence. However, at this stage, no single authority governed the entire network. Power remained diffuse. Trade continued to operate through overlapping, partially autonomous systems.
Exchange networks also transmitted information alongside goods. Knowledge about distant regions, technologies, and customs traveled with traders. This informational flow had long-term consequences. Techniques spread across regions through repeated contact. Innovations diffused without formal dissemination. Trade acted as a conduit for learning. The mechanism was indirect but persistent. Traders observed practices in different locations. They carried stories, tools, and methods back with them. Over time, these elements were adapted locally. The result was gradual convergence in certain technologies. Metallurgy, agriculture, and textile production all spread through exchange networks. Historical evidence supports this role of trade in diffusion. During the Bronze Age, similar metalworking techniques appeared across wide regions of Eurasia. At the time, there was no centralized authority coordinating this spread. Artifact analysis shows parallel development linked by trade routes. Exchange enabled convergence without uniformity. Trade also influenced social organization. Communities engaged in long-distance exchange developed norms around hospitality and negotiation. These norms reduced conflict and facilitated repeated interaction. Social institutions evolved to support exchange. Markets, fairs, and seasonal gatherings emerged as coordination points. These were not yet formal markets, but they served similar functions. According to anthropological studies, such gatherings often coincided with religious or cultural events. This alignment reduced risk by embedding trade within shared rituals. Trust was reinforced through repeated interaction. Exchange became predictable even among strangers. Social structure and trade co-evolved. As networks expanded, disparities in access emerged. Some communities were better positioned to benefit from exchange. Those controlling routes or scarce resources gained influence. However, this influence remained limited by the decentralized nature of early networks. No single node dominated entirely. Balance persisted through redundancy. These dynamics set the stage for later institutional developments. The patterns of movement, specialization, and intermediation were already in place. What remained was the formalization of authority. The architecture was forming beneath the surface. By the late prehistoric period, trade networks had reached continental scales. The Silk Road, in its early forms, connected East Asia with Central Asia and beyond. Amber routes linked northern Europe to the Mediterranean. These networks were not single roads, but overlapping corridors. Goods moved in stages, passing through many hands. Scale increased through accumulation rather than expansion. The process worked because each segment of the route was locally viable. Traders specialized in familiar regions. They exchanged goods with neighboring networks rather than traversing entire distances. This reduced risk and knowledge requirements. Long-distance trade emerged from short-distance exchanges, stitched together. Complexity arose from simplicity. Historical records from Han Dynasty China describe trade with Central Asian intermediaries. At the time, silk moved westward, while horses and metals moved eastward. These exchanges were mediated by multiple groups. No single trader controlled the entire route. The network functioned through cooperation and competition. The mechanism of staged exchange allowed resilience. Disruptions in one region did not halt the entire flow. Goods could be rerouted or delayed. The system adapted organically. This flexibility was critical in unstable environments. Trade persisted despite political fragmentation. According to studies by the World History Association, early transcontinental trade volumes were modest but consistent. The significance lay not in quantity, but in connectivity. These routes linked distant economies conceptually as well as materially. Awareness of other regions expanded. The idea of a wider world began to take shape. Exchange also influenced value systems. Goods acquired different meanings as they moved. Spices, silk, and precious metals became symbols of status far from their source. Their scarcity increased perceived value. This created demand that sustained long-distance trade. Cultural perception became an economic driver. These dynamics reinforced the architecture of trade. Networks became layered, with local, regional, and trans-regional components. Each layer operated according to its own logic. Together, they formed an integrated system without centralized design. The foundations of global trade were firmly in place. By the time written history becomes more detailed, trade networks were already deeply embedded in human societies. They shaped settlement, production, and social organization. Exchange was no longer peripheral, it was a core organizing force. The architecture had emerged incrementally over thousands of years. The reason these early systems endured lies in their adaptability. They were not rigid structures, but evolving patterns. When conditions changed, routes shifted. When demand altered, production adapted. This flexibility allowed trade to persist across environmental and political change. Stability emerged from motion rather than control. Early trade networks also demonstrated the limits of decentralization. While resilient, they were constrained by scale. Coordination relied on trust and tradition. As volumes increased, these mechanisms faced strain. The need for formal institutions would grow. The seeds of future transformation were already present. According to economic historians, the transition from informal exchange to institutionalized trade was gradual. There was no single turning point. Instead, layers of organization accumulated over time. Contracts, currencies, and states would later formalize what already existed. Institutions followed practice. The architecture of global trade did not begin with empires or corporations. It began with paths worn by repeated movement.
It grew through habits, not plans. By understanding these origins, later developments become clearer. Complexity did not replace simplicity, it was built upon it. These early networks established the fundamental logic of trade: reduce friction, specialize production, and connect through exchange. This logic would persist even as technologies and institutions changed. The next phase would test its limits. Authority, regulation, and power were about to enter the system.
The informal networks that shaped early exchange did not operate in abstract space. They were embedded in physical landscapes that rewarded some movements and discouraged others. Geography shaped what could be traded, how far goods could travel, and which communities became connected over time. Before formal institutions emerged, terrain acted as the first regulator of trade. Natural features imposed costs, created incentives, and structured opportunity. The most favorable environments for early trade were those that reduced friction almost automatically. Rivers allowed heavy goods to move with minimal effort, concentrating exchange along predictable corridors. Coastal waters extended this logic across longer distances, connecting settlements that shared access to the sea. These routes did not require advanced technology, only repetition and familiarity. Over time, they became reliable pathways for exchange. Inland movement was more demanding and therefore more selective. Forests slowed transport and obscured routes, while mountains imposed steep energy costs on movement. Deserts created extreme constraints, limiting passage to narrow windows and known crossings. These environments did not prevent trade entirely, but they forced specialization in methods and timing. Communities that learned to navigate them gained disproportionate influence. The mechanism underlying these patterns was simple. Where movement was easier, exchange intensified. Where movement was costly, trade narrowed to high-value goods that justified the effort. This logic shaped not only routes, but also the composition of trade itself. Bulk staples moved along rivers, while luxury items crossed deserts and mountains. Over time, repeated movement transformed geography into infrastructure. Footpaths became roads through use rather than design. River landings evolved into ports as traffic increased. What began as informal adaptation slowly hardened into spatial patterns that persisted across generations. Geography provided the frame, but human activity filled it in. These early routes also shaped settlement patterns. Villages clustered near crossings, ports, and junctions where flows converged. Markets emerged where routes intersected, not because of planning, but because exchange required coordination. Population density followed accessibility rather than political authority. Economic gravity pulled people toward movement. Historical records suggest this process unfolded unevenly across regions. By 3000 BCE, river-based trade networks along the Nile, Tigris, and Euphrates had already stabilized into durable corridors. At the time, these rivers supported predictable seasonal flows that aligned with agricultural cycles. Archaeological evidence shows repeated exchange of grain, textiles, and tools along these waterways. Geography and subsistence reinforced each other. In South and East Asia, monsoon systems played a similar role. Seasonal wind patterns allowed ships to travel predictable maritime routes across the Indian Ocean. By the first millennium BCE, merchants timed voyages to these cycles, reducing uncertainty. This created early long-distance maritime circuits without centralized control. Nature provided coordination where institutions did not yet exist. Early land routes developed more slowly but became equally significant. Between 1000 BCE and 500 CE, a network of paths, later known as the Silk Roads, connected East Asia to the Mediterranean. These routes crossed deserts and mountains, requiring relay systems and specialized knowledge. Trade volumes were limited, but the geographic linkage was durable. High-value goods justified the effort. The structure of these routes mattered more than their length. Trade did not move continuously from one end to another. Instead, goods passed through chains of intermediaries, each operating within familiar terrain. Geography segmented exchange into manageable zones. The system worked because no single actor needed to traverse the entire route. This segmentation reduced risk but increased dependency. Disruption in one region could interrupt flows far beyond its borders. Yet the same fragmentation also allowed resilience. When one path failed, alternatives could emerge nearby. Geography produced both vulnerability and flexibility. The absence of centralized control meant that routes adapted gradually. Shifts in climate, water levels, or political stability redirected movement over time. No authority dictated these changes. They emerged from accumulated choices. Trade followed paths of least resistance until resistance changed. Geography remained the primary constraint. By the early centuries of the Common Era, these patterns had become deeply embedded. Routes were known, maps hazards, and rhythms internalized. Even as states began to form, they inherited these spatial arrangements rather than creating them anew. The landscape had already written much of the script. What mattered most was not the existence of trade, but its direction and density. Geography concentrated flows in some regions while leaving others peripheral. This unevenness would later shape power, wealth, and institutional development. The map of trade was already unequal. As volumes increased, the limits of purely geographic coordination became clearer. Natural routes could support exchange, but not governance. The stage was set for new mechanisms to manage what geography had enabled. The persistence of trade routes depended on more than physical features alone. Social knowledge accumulated around geography, turning environmental constraints into shared systems of movement. Navigational techniques, seasonal timing, and local expertise became critical complements to terrain. Geography created possibility, but knowledge sustained continuity. Trade routes were as much cognitive maps as physical ones. This process worked because information reduced uncertainty. When travelers knew where water could be found, where shelter existed, and where exchange was expected, movement became routine. Over time, this knowledge was transmitted through apprenticeship and repetition. Routes stabilized not because they were optimal, but because they were known. Familiarity lowered perceived risk. The mechanism operated incrementally. Each successful journey reinforced confidence in a path. Each exchange created expectations of future encounters. Gradually, trust attached not only to people, but to places. Geography and reputation merged into durable corridors of movement. This also meant that trade routes were selective. They favored regions capable of supporting repeated passage. Areas lacking water, forage, or security remained marginal despite proximity. Geography filtered participation long before formal barriers existed. Access was earned through navigability. Historical accounts from the classical antiquity reflect this pattern. By the 5th century BCE, Greek traders relied on established maritime lanes across the Aegean and Mediterranean. At the time, coastal navigation minimized exposure to open seas. Harbors became critical nodes, offering shelter and exchange. Trade clustered around these natural assets. Inland Europe followed a different trajectory. River systems such as the Rhine and Danube structured movement across large distances. Goods moved downstream more easily than upstream, shaping directional trade balances. Settlements adapted by specializing in goods suited to their position along the flow. Geography dictated economic roles. In the Americas, similar patterns emerged independently. By the first millennium CE, extensive trade networks connected Mesoamerica through a combination of riverine and overland routes. Archaeological evidence shows obsidian and cacao moving across hundreds of kilometers. Terrain constrained volume, but not reach. High-value goods overcame distance. These examples reveal a consistent structure. Geography did not determine outcomes absolutely, but it shaped probabilities. Regions with favorable terrain accumulated connections earlier and more densely. Peripheral areas joined later or remained specialized. Trade networks expanded unevenly. The analytical implication is straightforward. When transport costs vary by route, exchange concentrates where costs are lowest. This concentration creates hubs that attract further activity. The process is self-reinforcing. Geography initiates clustering long before institutions formalize it. As hubs grew, they altered surrounding landscapes. Roads were improved, ports expanded, and way stations established. These modifications reduced friction further, amplifying initial advantages. Human intervention began to reshape geography in response to trade. The boundary between natural and built environments blurred. Yet these improvements remained localized. Without centralized coordination, infrastructure followed demand rather than planning. This limited integration across regions. Trade expanded outward from hubs but did not equalize conditions everywhere. Geography continued to impose hierarchy. Records from the Roman period illustrate this dynamic. By the 2nd century CE, a dense network of roads connected key urban centers. These routes often followed older paths shaped by terrain. Investment reinforced existing corridors rather than creating new ones. Geography constrained imperial ambition. Maritime trade followed a similar logic. Prevailing winds and currents defined viable routes, even for advanced fleets. Seasonal closures persisted despite political power. Geography resisted full control. States adapted to it rather than overcoming it entirely. The result was a layered system. Natural features defined primary routes. Knowledge and habit stabilized them. Incremental infrastructure intensified use. Together, these elements produced durable trade geographies that outlasted individual regimes. The system was robust, but not unified. As trade volumes grew, coordination challenges multiplied. Geography could guide movement, but it could not resolve disputes or enforce standards. The complexity generated by expanded routes would soon exceed informal mechanisms. pressure was building for new forms of organization. The expansion of trade routes revealed both the strengths and limits of geography-driven systems. While terrain structured movement efficiently, it offered no mechanism for uniform regulation. Each region operated according to local conditions and customs. This diversity enabled flexibility, but hindered integration. The system scaled outward, but not upward. The reason for this limitation lay in fragmentation. Routes connected places, but they did not synchronize them. Measures, weights, and expectations varied along the path. Exchange required constant negotiation. Geography facilitated contact, not consistency. As a result, intermediaries became increasingly important. Traders who specialized in specific segments of routes managed transitions between regions. Their role was not only logistical, but informational. They translated between local norms. Geography created the need for mediation. Historical evidence from late antiquity shows this pattern intensifying. Between the 3rd and 7th centuries CE, long-distance trade persisted despite political fragmentation. Merchant communities maintained routes across shifting borders. Geography provided continuity where states did not. Yet coordination costs remained high. In the Islamic world, expansion across diverse terrains reinforced these dynamics. Trade routes linked deserts, mountains, and seas into a broad network. Caravan routes required precise knowledge of terrain and timing. Maritime routes depended on monsoon cycles. Geography remained the organizing principle. At the same time, emerging authorities began to recognize the value of controlling routes rather than territory alone. Taxation focused on choke points, such as ports, passes, and crossings. Power attached to geography strategically. Control of movement translated into revenue. This shift marked a subtle change. Geography no longer merely constrained trade, it became an asset to be managed. States did not replace routes, but they sought to anchor authority to them. The landscape became politicized. Trade routes attracted oversight. The mechanism behind this transition was cumulative. As volumes increased, the benefits of coordination grew. Standardized rules reduced friction across regions. Enforcement became valuable. Geography had created the network, institutions promised to stabilize it. By the medieval period, this interplay was evident across Eurasia. Major routes persisted, but governance layered over them unevenly. Some corridors remained loosely regulated, others heavily taxed. Geography set the baseline, institutions modified the surface. Neither operated alone. Maritime expansion further tested these arrangements. Open seas reduced reliance on fixed routes, but ports remained essential. Geography shifted from linear paths to nodal networks. Control focused on entry points rather than corridors. The logic adapted without disappearing. Throughout these changes, the foundational influence of geography endured. Even as technologies improved, transport costs remained uneven. Distance mattered less than friction. Natural features continued to shape economic possibilities. The architecture remained grounded in terrain. This persistence explains why trade systems evolved gradually. Geography imposed continuity across eras. New mechanisms adapted to existing routes rather than replacing them wholesale. Innovation layered onto constraint. The system absorbed change without resetting. As the scale of trade expanded further, informal adaptations reached their limits. Geography could no longer coordinate complexity alone. The need for standardized mechanisms became unavoidable. What followed was not a rejection of geography, but an attempt to govern what it had made possible. The routes remained. The question became how they would be managed. The next phase would focus on the mechanisms that allowed trade to operate at scale. Geography had built the skeleton. Systems would now add structure.
The routes that geography made possible did not remain unmanaged indefinitely. As exchange intensified, especially across water, new forms of organization began to appear. Maritime trade introduced both opportunity and risk at a scale unseen in overland systems. The sea reduced friction dramatically, but it also amplified uncertainty. Coordination could no longer rely solely on habit. Water fundamentally altered the economics of movement. Ships could carry volumes far exceeding any land-based transport. Once afloat, distance mattered less than weather, navigation, and access to ports. The mechanism was transformative. Lower per-unit transport costs expanded the range of viable goods. This shift favored certain regions immediately. Coastal settlements with natural harbors became gateways rather than endpoints. Their importance derived not from production alone, but from access. Control over entry and exit points became economically decisive. Geography concentrated leverage. Maritime trade also altered time horizons. Sea voyages compressed travel time relative to overland routes. Goods circulated faster, capital turned over more quickly, and coordination across regions intensified. This acceleration changed expectations. Reliability became more valuable than mere access. Early maritime networks remained decentralized at first. Sailors followed coastlines, moving between familiar ports. Knowledge of currents, winds, and hazards accumulated gradually. Repetition stabilized routes without formal oversight. The sea, like rivers before it, rewarded familiarity. Historical records show this pattern emerging early in the Mediterranean. By 1500 BCE, seaborne trade linked Egypt, the Levant, and the Aegean. At the time, ships hugged coastlines and relied on seasonal winds. Cargoes included grain, timber, metals, and luxury goods. Exchange volumes exceeded anything possible over land. The Indian Ocean followed a parallel trajectory. By the early centuries BCE, merchants were exploiting predictable monsoon cycles. Voyages linked East Africa, Arabia, India, and Southeast Asia. Timing was critical. Departure windows dictated the rhythm of trade. These systems expanded reach without requiring territorial control. Merchants operated across cultural and political boundaries. Ports functioned as neutral zones where exchange could occur. Authority was fragmented. Geography still dominated organization. As volumes increased, vulnerabilities became apparent. Ships represented concentrated value. Losses from storms or piracy were catastrophic. Trust-based systems struggled to manage risk at scale. Informal norms faced strain. The reason lay in asymmetry. Maritime trade aggregated goods, capital, and labor into a single vessel. Failure meant total loss. This concentration demanded new mechanisms for protection and coordination. The sea rewarded scale, but punished disorder. Responses emerged unevenly. Some communities developed convoy systems, others invested in naval protection. Gradually, political authority began to intersect with maritime exchange. The boundary between commerce and power blurred. Empires did not initially create maritime trade, they inherited it. What they offered was standardization layered on top of existing routes. Rules, enforcement, and infrastructure followed flows rather than preceding them. Authority attached to movement. The earliest maritime empires focused on securing choke points. Narrow passages, straits, and harbors offered leverage disproportionate to territory. Control of these nodes translated into influence over entire networks. Geography again defined strategy. This logic reshaped political organization.
power became less about land area and more about connectivity. Maritime empires optimized for flow. They governed corridors rather than continuous space. The transition was gradual. States experimented with taxation, protection, and regulation. Some succeeded, others failed. What mattered was alignment with existing maritime geographies. Systems that complemented routes endured.
As maritime trade expanded, states learned to monetize movement itself. Rather than producing goods, they extracted value from facilitating exchange. Ports became fiscal instruments. Customs duties replaced tribute. The mechanism was indirect but powerful. This worked because maritime trade generated predictable flows. Ships arrived in cycles. Cargoes could be assessed and taxed. Revenue became tied to throughput rather than harvest. This stabilized state finances. Historical evidence from classical antiquity illustrates this shift. By the 1st century CE, Roman authorities had established customs stations at major ports. At the time, grain shipments from Egypt supplied urban populations. Control of maritime routes underpinned political stability. Trade supported empire. Rome did not centralize trade operations fully. Private merchants remained dominant. What the state provided was security and standardization. Coinage, legal frameworks, and infrastructure reduced transaction costs. The sea became governable. Similar dynamics appeared elsewhere. In Han China, maritime routes complemented overland networks. Coastal trade linked river systems to external markets. State oversight focused on ports rather than ships. Geography constrained intervention. The analytical pattern is consistent. When transport costs fall sharply, scale increases. As scale increases, coordination becomes valuable. States intervene not to replace markets, but to stabilize them. Maritime trade created the conditions for empire. Empires, in turn, reshaped trade patterns. Investment in ports, shipbuilding, and navigation expanded capacity. Routes intensified along protected corridors. Peripheral paths declined. Authority redirected flow. Yet control remained incomplete. The sea resisted total domination. Storms, distance, and information gaps limited oversight. Maritime empires relied on incentives as much as coercion. Cooperation mattered. Between the 7th and 15th centuries, Islamic caliphates exemplified this balance. Maritime trade across the Indian Ocean flourished under loose imperial frameworks. Merchants retained autonomy. Legal norms standardized contracts and credit. Power facilitated exchange without monopolizing it. In Southeast Asia, port polities emerged with similar characteristics. Control of harbors mattered more than hinterlands. These states thrived by intermediating trade rather than extracting resources. Geography favored nodal governance. European maritime expansion later followed these precedents. By the 15th century, Atlantic navigation extended existing logic. Ships connected continents directly. Scale increased again. Risk multiplied. The response was institutional innovation. Joint stock companies, marine insurance, and naval enforcement evolved together. According to economic historians, these mechanisms reduced individual exposure while preserving aggregate risk-taking. Trade accelerated further. Empires now operated through corporations as well as states. Authority was delegated. Geography expanded, but governance remained uneven. Maritime trade outpaced political control. This imbalance produced tension. Profits concentrated. Competition intensified. Violence followed routes. The sea became contested space.
Yet even conflict reinforced structure. Naval power protected corridors. Treaties formalized access. Trade geography hardened further. Empires organized around maritime systems they could not fully command. The result was a layered architecture. Geography defined possibility. Trade exploited it. Empires stabilized parts of the system. No layer replaced the others. Maritime trade thus transformed global exchange without dissolving earlier constraints. It amplified patterns rather than erasing them. The sea expanded reach, but it did not eliminate friction.
The long-term consequences of maritime empires was integration without uniformity. Oceans connected distant regions, but governance remained fragmented. Trade flowed through networks of ports, firms, and states operating under partial coordination. Complexity increased. This structure produced resilience. Disruptions in one region could be bypassed via alternative routes. Maritime networks adapted quickly. Flexibility compensated for fragility. Geography again mattered. At the same time, dependence deepened. Regions specialized based on access to maritime trade. Coastal economies diverged from inland ones. Inequality widened. Connectivity shaped development trajectories. By the early modern period, these dynamics were evident globally. European maritime powers dominated long-distance routes. Colonial systems reorganized production around shipping lanes. Raw materials flowed outward, manufactured goods inward. Geography structured hierarchy. The mechanism driving this pattern was cumulative advantage. Early access to maritime networks enabled investment in protection and technology. These investments reinforced dominance. Feedback loops emerged. According to studies by economic historians, shipping costs declined steadily between the 16th and 19th centuries. At the time, improvements in hull design and navigation increased reliability. Volumes surged, markets expanded. Yet governance lagged. Regulation varied by empire. Legal fragmentation persisted. Trade required constant negotiation across jurisdictions. Institutions remained layered rather than unified. This condition set the stage for later transformations. As maritime trade reached global scale, coordination problems multiplied. Standardization became valuable. Informal empire proved insufficient. The persistence of geography remained evident. Even with steam power and canals, choke points retained significance. Control of passages such as the Suez and Panama reshaped flows. Geography continued to anchor strategy. Maritime empires adapted by focusing on infrastructure. Canals, ports, and coaling stations extended reach. Investment followed routes. Power aligned with movement. Yet these adaptations also revealed limits. Infrastructure required capital and cooperation. Political stability mattered. Trade systems grew sensitive to disruption. Vulnerability increased alongside scale. By the late 19th century, maritime trade had become the backbone of global exchange. Empires depended on it. Economies synchronized around shipping cycles. The system was vast, but fragile. The architecture now required more than protection. It required coordination across states, firms, and regions. Geography had enabled expansion. Maritime empires had stabilized parts of it, but complexity demanded new forms of governance. This transition did not discard maritime systems, it built upon them. Roots persisted,
institutions layered over empires. The next phase would focus on mechanisms that supported trade beyond imperial reach. Maritime trade had stretched the system outward. What followed would attempt to bind it together.
Industrialization altered the architecture of global trade by shifting its center of gravity from routes to systems. Maritime empires had extended exchange across oceans, but industrial economies required something more durable than access alone. Production volumes increased beyond the capacity of ad hoc coordination. Goods were no longer scarce, customized, or episodic. They were standardized, repeatable, and continuous. This change transformed trade from an activity into an infrastructure. The movement of goods had to become predictable at scale, synchronized with factories, labor schedules, and consumption cycles. Time became as important as distance. Delays now propagated backward into production and forward into markets. Trade systems responded by embedding logistics directly into industrial organization. Ports, railways, warehouses, and accounting systems ceased to be peripheral supports. They became the operating skeleton of economic exchange, binding distant regions into a single functional unit whose stability depended on coordination rather than conquest. The mechanism driving this shift was the industrial separation of production from consumption. Factories concentrated labor and machinery in fixed locations, while demand remained geographically dispersed. This created a structural gap that only logistics could bridge. The reason industrial trade required new coordination was that volume magnified error. Small inefficiencies multiplied across thousands of shipments and millions of units. This worked because industrial production relied on steady throughput rather than episodic exchange. Raw materials had to arrive on schedule, and finished goods had to leave immediately to avoid bottlenecks. Storage became a strategic variable rather than a passive buffer. Firms invested in scheduling, inventory management, and contractual reliability. Transport was reorganized around timetables instead of availability. Risk shifted from piracy and weather to congestion and misalignment. The system increasingly rewarded predictability over reach. Trade architecture evolved into a network designed to minimize variance rather than maximize expansion, reshaping how power and profit were distributed within the system. By the mid-19th century, railways emerged as the critical inland counterpart to maritime trade. By 1850, Britain had laid more than 6,000 miles of track, linking coal fields, factories, and ports. Similar expansions followed in Western Europe and the United States. At the time, railways did more than accelerate movement. They standardized space by imposing uniform gauges, schedules, and pricing structures. This integration allowed inland production zones to participate directly in global trade. Agricultural regions were drawn into export circuits, while industrial centers accessed distant inputs. Rail networks synchronized local economies with maritime shipping cycles. The architecture of trade became layered, with sea lanes feeding rail corridors that extended exchange deep into continental interiors. This reduced dependence on navigable rivers and seasonal transport. It also increased capital requirements, tying trade expansion to financial systems capable of funding long-lived infrastructure. Industrial logistics also transformed ports from exchange points into processing nodes. According to Port Authority records and commercial studies of the late 19th century, major harbors expanded storage, handling equipment, and administrative capacity. Docks were redesigned to accommodate standardized cargo and faster turnaround times. Warehouses multiplied, separating ownership transfer from physical movement. Studies show that ports handling bulk industrial goods reduced per-unit costs primarily through organizational improvements rather than sheer scale. Customs procedures were rationalized to reduce delays. Insurance, inspection, and documentation clustered near terminals. These changes reflected a broader shift in trade governance. Control moved from imperial officials to hybrid systems involving firms, financiers, and municipal authorities. Ports became logistical cities whose efficiency shaped national competitiveness. Their success depended less on geography alone and more on institutional coherence and investment continuity. The rise of mass logistics also altered the temporal rhythm of trade. Maritime systems had tolerated irregularity, absorbing delays through inventory and price fluctuations. Industrial systems could not. Factories depended on continuous input flows, and markets expected consistent supply. The mechanism enforcing this discipline was contractual obligation. Firms committed to delivery schedules backed by penalties and insurance. This worked because industrial markets valued reliability over opportunistic advantage. Transport providers adapted by offering guaranteed services at fixed rates. Telegraph networks enabled real-time coordination across distances, reducing informational lag. Time zones were standardized to synchronize schedules. Trade architecture incorporated temporal alignment as a design principle. The result was a system less flexible but more stable under normal conditions. Efficiency gains accumulated, but resilience to disruption diminished, embedding new forms of systemic risk within global exchange. By the late 19th century, industrial powers began formalizing logistical governance beyond national borders. By 1875, international conventions addressed rail interoperability, shipping standards, and commercial law. At the time, these agreements reflected recognition that fragmented rules imposed hidden costs on trade. Harmonization reduced friction but required sustained cooperation. Private firms played a central role, lobbying for standards that aligned with their operational models. Financial institutions supported these efforts, as predictable logistics stabilized returns on infrastructure investment. Trade associations disseminated best practices across regions. This institutional layering did not eliminate competition, it structured it. States retained sovereignty, but firms operated within increasingly uniform logistical environments. The architecture of trade thus evolved into a semi-coordinated system, balancing national interests with transnational operational efficiency. According to economic historians and logistics studies, the industrial trade system's greatest strength was its capacity for scale. Studies show that standardized logistics reduced marginal transport costs even as volumes increased. This effect encouraged further concentration of production and distribution. Large firms outperformed smaller ones by internalizing logistics functions. Vertical integration spread, aligning production, transport, and sales within single organizations. This worked because coordination costs declined relative to output. However, the same studies note that complexity increased non-linearly. Dependencies multiplied across suppliers, carriers, and markets. A disruption in one node propagated rapidly through the system. The architecture became tightly coupled. Stability depended on continuous operation across all layers. The system could absorb shocks only if they were localized and brief, revealing a structural trade-off between efficiency and resilience. Industrial logistics matured through the consolidation of firms and the formalization of supply chains. Early industrial trade relied on networks of independent producers, carriers, and merchants. Over time, coordination costs pushed these actors toward integration. Large firms absorbed transport, storage, and distribution functions directly into their operations. This reduced uncertainty but increased organizational scale. Trade architecture shifted from open networks to managed systems. Decisions about movement were no longer reactive responses to market signals. They were planned in advance, optimized across entire production cycles. This planning required detailed information about inputs, outputs, and transit conditions. Record-keeping expanded from simple ledgers to complex accounting systems capable of tracking flows across regions. The result was a trade system governed internally by firms rather than externally by markets alone. Exchange still occurred, but within frameworks designed to stabilize throughput rather than maximize price advantage. The mechanism enabling this consolidation was the declining cost of coordination relative to transport. Industrial technologies increased output faster than they reduced friction. The reason firms integrated logistics was that transport delays disrupted production schedules more severely than price fluctuations. This worked because factories operated with high fixed costs and narrow margins for interruption. A stopped assembly line incurred losses regardless of market conditions. Firms responded by exerting greater control over movement and storage. Ownership of rail spurs, warehouses, and shipping contracts became strategic assets. Management structures expanded to oversee logistics alongside production. Information systems standardized reporting across units. The architecture of trade thus internalized many functions previously handled by independent intermediaries. Power shifted toward organizations capable of managing complexity at scale, reshaping competitive dynamics across industrial economies. By the late 19th century, industrial cartels and trusts reflected this structural change. By 1890, industries such as steel, oil, and chemicals exhibited high degrees of vertical integration in Europe and North America. At the time, these firms coordinated extraction, processing, transport, and distribution within unified systems. Rail agreements guaranteed preferential rates. Ports constructed specialized terminals dedicated to specific commodities. Warehouses were located adjacent to factories, reducing handling time. These arrangements reduced transaction costs but limited market entry. Smaller firms struggled to access infrastructure on equal terms. Trade architecture became less open but more efficient. The system favored continuity over experimentation, reinforcing existing industrial hierarchies while extending their reach across borders. Industrial logistics also altered labor organization within trade systems. According to labor studies and port records, dock work, rail operation, and warehousing shifted from casual employment to regulated occupations. Standardized schedules required predictable labor availability. Training became necessary to operate machinery and manage inventories. Unions emerged to negotiate wages and working conditions within increasingly centralized systems. Studies show that labor disputes posed significant risks to logistical continuity. Firms and states responded by formalizing labor relations through contracts and regulations. This integration of labor into trade architecture reflected recognition that human coordination was as critical as mechanical efficiency. The smooth movement of goods depended on disciplined workforces aligned with industrial timetables, embedding social structures directly into logistical design. The expansion of mass logistics also reshaped consumption patterns. Industrial distribution systems enabled goods to reach broader markets with consistent quality and pricing. Retail networks expanded, supported by reliable replenishment cycles. The mechanism linking logistics to consumption was predictability. This worked because consumers adjusted expectations around availability and price stability. Seasonal scarcity diminished for industrial goods. Marketing strategies evolved to emphasize regular supply rather than novelty. Firms invested in distribution centers positioned to serve regional markets efficiently. Demand became more synchronized across regions, reinforcing the scale advantages of industrial firms. Consumption patterns in turn fed back into production planning, tightening the coupling between market behavior and logistical systems. By the early 20th century, industrial powers began exporting logistical models alongside goods. By 1910, rail standards, port designs, and warehouse practices developed in Europe and North America were replicated in colonial and semi-industrial regions. At the time, these transfers aimed to integrate local economies into global supply chains. Infrastructure projects aligned local production with industrial demand abroad. Financial institutions supported these efforts, anticipating stable returns from predictable trade flows. This diffusion extended the reach of industrial logistics but deepened dependency. Peripheral regions specialized in supplying inputs while importing finished goods. The architecture of trade thus reproduced industrial hierarchies on a global scale, embedding asymmetry within logistical design rather than explicit political control. According to economic analyses and trade statistics, the integrated industrial system delivered unparalleled efficiency gains. Studies show that transport costs as a share of final prices declined steadily despite rising volumes. Inventory turnover increased, reducing capital tied up in storage. These improvements supported sustained economic growth. However, analyses also highlight increasing systemic risk. Tightly coupled systems amplified shocks. Disruptions in transport or production cascaded rapidly across regions. Firms mitigated risk through redundancy and insurance, but complete insulation was impossible. The architecture prioritized throughput over adaptability. Its success depended on stable conditions and continuous coordination. As scale increased, so did vulnerability to disturbances beyond the control of individual actors. Industrialization bound global trade into a coherent logistical system governed by organizations rather than empires. Authority derived from operational control instead of territorial dominance. The architecture integrated production, movement, labor, and consumption into synchronized processes. This coherence enabled expansion without conquest, yet it also constrained flexibility. Trade systems grew dense, interdependent, and sensitive to interruption. The logic of mass logistics emphasized efficiency, predictability, and scale. These principles stabilized industrial exchange while narrowing margins for error. As the system extended across continents, its dependence on coordination deepened, setting conditions under which disruption would no longer remain localized, but propagate through the very mechanisms designed to sustain global trade.
Industrial mass logistics reached maturity when coordination became systemic rather than organizational. Firms, states, and financial institutions increasingly depended on shared assumptions about timing, capacity, and reliability. Trade architecture no longer consisted of discrete networks stitched together by contracts. It functioned as an integrated environment within which actors operated according to common constraints. Production decisions were made with full awareness of transport schedules, storage limits, and market absorption rates. The movement of goods followed predefined pathways optimized for volume and regularity. Deviations imposed costs across multiple layers simultaneously. This alignment transformed logistics from a competitive differentiator into a baseline requirement. Participation in global trade now depended on conformity to system standards. Efficiency gains continued, but strategic autonomy narrowed. The architecture stabilized exchange by enforcing uniform behavior, embedding discipline into the structure itself rather than relying on individual coordination alone. The mechanism sustaining this environment was infrastructural lock-in. Once capital-intensive systems were established, alternatives became prohibitively expensive. The reason coordination hardened was that industrial infrastructure required long amortization periods. Rail networks, ports, and warehouses could not be easily repurposed without losses. This worked because investment decisions assumed stable trade volumes and predictable routes. Financial institutions reinforced this assumption by structuring credit around long-term usage. Firms optimized operations within existing layouts rather than redesigning systems. Innovation focused on incremental efficiency rather than structural experimentation across trade systems. As a result, trade architecture favored continuity. Path dependence shaped outcomes more strongly than market signals. The system became resilient to small fluctuations, but resistant to adaptation, constraining responses to emerging pressures and unforeseen disruptions. By the early 20th century, mass logistics had become central to national economic planning. By 1914, industrial states maintained detailed assessments of transport capacity, stockpiles, and supply routes. At the time, these assessments were driven by both commercial and strategic concerns. Governments recognized that industrial economies depended on uninterrupted trade flows. Rail and port infrastructure was mapped as national assets. Regulatory frameworks aligned private logistics with public priorities. During periods of strain, states intervened directly to allocate capacity and control movement. These practices demonstrated that logistical coordination had become inseparable from governance. Trade architecture extended into state apparatuses, blurring distinctions between market operations and public administration within industrial economies. Industrial logistics also reshaped financial systems supporting trade. According to banking records and commercial studies, credit increasingly followed goods rather than firms. Bills of lading, warehouse receipts, and standardized documentation enabled financing based on movement and storage. Studies show that this reduced information asymmetry and lowered borrowing costs. Risk assessment focused on system reliability rather than individual counterparties. Insurance markets expanded to cover transit, delay, and interruption. These financial instruments reinforced logistical discipline by pricing deviation and uncertainty. Capital flowed toward routes and nodes with proven stability. The architecture of trade thus aligned finance with physical movement, integrating monetary systems directly into logistical design and further tightening interdependence across layers of exchange. The consolidation of mass logistics also influenced technological development.
Industrial innovation prioritized compatibility with existing systems. Machinery was designed to fit standardized containers, rail gauges, and warehouse layouts. The mechanism linking technology to logistics was scale. This worked because standardized systems allowed rapid diffusion of equipment and practices. Firms adopted technologies that enhanced throughput within established architectures. Radical alternatives faced barriers to adoption if they disrupted coordination. As a result, technological progress reinforced prevailing logistical models. Efficiency improved, but diversity declined. The architecture shaped innovation pathways, channeling development toward incremental optimization rather than structural experimentation across trade systems. By the interwar period, global trade exhibited unprecedented interdependence. By 1929, industrial economies were linked through dense logistical networks spanning production, transport, finance, and consumption. At the time, trade volumes reached historic highs relative to output. The system appeared stable, supported by mature infrastructure and institutional coordination. Yet underlying vulnerabilities accumulated. Dependency on continuous operation left little margin for disruption. Inventory buffers were minimized. Credit exposure expanded. Regional shocks transmitted rapidly through integrated networks. The architecture of mass logistics amplified both growth and fragility, embedding systemic risk within the very mechanisms that sustained global exchange. According to economic historians and system analyses, the defining feature of industrial trade architecture was coupling. Studies show that tightly coordinated systems outperform loosely connected ones under stable conditions. However, they also demonstrate greater sensitivity to shock. Disruptions propagate through synchronized schedules and shared infrastructure. Recovery requires system-wide realignment rather than local adjustment. These findings highlight the structural trade-offs embedded in mass logistics. Efficiency gains were achieved by reducing slack and redundancy. This choice increased exposure to systemic failure. The architecture prioritized predictable performance over adaptive capacity, reflecting assumptions of continuity that would later be challenged by large-scale disruptions. Industrialization bound global trade into a single operational framework governed by logistics rather than territory. Movement became continuous, standardized, and financially integrated. Coordination replaced expansion as the primary challenge. The architecture delivered scale, efficiency, and growth, but at the cost of flexibility. Vulnerability was no longer peripheral, it was structural. As mass logistics extended across regions and sectors, disruption threatened entire systems rather than isolated routes. This condition did not halt expansion, but it altered its character. Trade systems became powerful yet brittle, optimized for normal operation and exposed under strain. The mechanisms forged during industrialization would shape how global trade responded when coordination itself became the limiting factor.
Industrial mass logistics left global trade powerful yet exposed, efficient yet fragile, and increasingly dependent on coordination rather than territorial expansion alone. As production scaled and movement accelerated, the central challenge shifted toward maintaining alignment across vast networks operating without shared culture, proximity, or continuous negotiation. Standardization emerged as the primary response to this condition, offering stability where flexibility had been lost. Instead of relying on trust or localized convention, trade systems adopted formal rules that reduced interpretive variation across transactions. These rules governed how goods were classified, measured, priced, insured, documented as they moved through interconnected systems. By narrowing acceptable differences, standardization replaced interpersonal judgment with procedural consistency embedded into daily operations. Coordination costs declined as predictability increased, allowing organizations to function across distance with minimal friction. Yet this same process quietly concentrated dependence within uniform structures that assumed normal operation as the default state of exchange. Standardization did not originate as a single reform or coordinated global project, but as a layered accumulation of practices responding to recurring inefficiencies. Merchants, manufacturers, and transport operators repeatedly encountered losses caused by mismatched expectations rather than physical obstacles. Variations in weights, measures, packaging, terminology, and documentation produced delays that compounded as volumes increased. Each inconsistency required resolution, often through negotiation, inspection, or arbitration, consuming time and capital. As trade intensified, these frictions became intolerable at scale. The mechanism was straightforward. Reducing interpretive discretion reduced transactional delay. This worked because uniform inputs allowed processes to be automated, sequenced, and delegated without constant oversight. Over time, informal conventions hardened into codified standards enforced through contracts, institutions, and infrastructure. What began as practical alignment evolved into an architectural feature of global exchange, shaping how systems were designed and operated. By the late 19th century, industrial economies were actively formalizing standards to support expanding trade volumes. Measurement systems were rationalized, with national governments promoting uniform weights and measures to facilitate taxation and commerce. At the time, railways required standardized gauges, schedules, and signaling systems to operate across regions without interruption. Shipping adopted standardized documentation to manage growing cargo complexity, including bills of lading and manifests. Commodity exchanges codified grades and classifications to allow goods to be traded sight unseen. By 1900, industrial trade relied increasingly on paper representations that stood in for physical inspection. These developments reflected a broader shift toward abstraction within trade systems. Goods were no longer valued solely as physical objects, but as standardized units compatible with financial, legal, and logistical processes. This abstraction allowed markets to expand while remaining governable. Standardization also reshaped institutional roles within global trade, redistributing authority away from individual actors towards systems of verification. Inspectors, certifying bodies, and regulatory agencies emerged to enforce compliance with shared specifications. The reason this became necessary was scale, as personal reputation could no longer guarantee reliability across millions of transactions. This worked because third-party validation substituted institutional trust for interpersonal familiarity. Once embedded, standards enabled coordination across firms that never interacted directly. Contracts reference specifications rather than relationships, allowing transactions to proceed without negotiation over basic terms. Over time, compliance became a prerequisite for participation rather than a competitive advantage. Firms organized internal processes to meet external standards, aligning production, packaging, and documentation accordingly. Trade systems became less negotiable but more predictable, emphasizing conformity over adaptation. According to historical trade records and economic studies, the 20th century marked a decisive acceleration in global standardization efforts. International organizations formed to harmonize rules across borders, reducing national variation that impeded commerce. Studies show that standardized container sizes, pallet dimensions, and documentation formats significantly reduced handling costs and transit times. According to shipping industry analyses, uniform containerization alone transformed port operations by enabling mechanized loading and scheduling. Financial standards similarly aligned payment systems, credit instruments, and insurance practices across jurisdictions. These changes reinforced each other, as compatibility in one domain increased returns in others. According to institutional research, standardization generated network effects that rewarded early adoption and penalized deviation. Once established, standards proved difficult to modify, embedding historical decisions into long-term operational structures. The consolidation of standards altered the balance between resilience and efficiency within trade systems. Uniformity allowed processes to be optimized around predictable inputs, reducing redundancy and excess capacity. The mechanism favored throughput over adaptation, as systems assumed continuous flow rather than interruption. This worked because stable conditions allowed specialization to increase productivity across networks. However, the same assumptions limited the ability to respond to unexpected variation. When disruption occurred, standardized systems lacked alternative pathways designed for deviation. Local improvisation was constrained by global requirements that prioritized consistency. As a result, shocks propagated rapidly across interconnected structures. Standardization stabilized daily operation while amplifying systemic exposure during periods of strain. By the mid-20th century, standardization had become inseparable from governance in global trade. National policies increasingly aligned with international norms to maintain access to markets. At the time, regulatory convergence was framed as technical cooperation rather than political integration. Standards organizations expanded their influence by defining acceptable practice across industries. These bodies operated through consensus, yet their outcomes carried binding consequences. Compliance determined participation, while deviation resulted in exclusion or inefficiency. Over time, standards shaped not only how trade occurred, but which actors could compete effectively. Small variations became barriers rather than expressions of local preference. The architecture of trade favored alignment over diversity, reinforcing dominant practices through repetition. Standardization ultimately transformed coordination from an active process into a structural condition, embedded within systems themselves. Trade no longer depended on continuous agreement, but on adherence to predefined forms that assumed mutual recognition. This reduced friction while constraining choice, binding participants into shared operational logic. The system functioned smoothly when assumptions held, delivering scale, speed, and integration across regions. Yet this smoothness masked growing interdependence as deviation became increasingly costly. Uniform standards concentrated risk within tightly coupled networks optimized for regularity. As global trade advanced, coordination ceased to be negotiated and became enforced through architecture, leaving systems powerful, synchronized, and increasingly dependent on conditions remaining within expected bounds. As standards embedded themselves into trade systems, their influence extended beyond technical alignment into the deeper structure of economic coordination. Uniform rules began to shape behavior by defining what was permissible, efficient, and legible within global exchange. Actors adjusted not only to comply, but to optimize within these constraints. Trade schedules, inventory strategies, and investment decisions increasingly assumed standardized inputs and outputs. The architecture of trade became anticipatory, designed around expected conformity, rather than negotiated exception. This shift reduced uncertainty under normal conditions, allowing planning horizons to extend and capital to commit with greater confidence. At the same time, it narrowed the range of viable alternatives when circumstances changed. Coordination was no longer something achieved repeatedly through interaction. It was pre-configured into systems that operated according to shared assumptions. The mechanism through which standards enforced coordination was indirect yet powerful. By defining acceptable forms, standards filtered variation before transactions occurred. This worked because incompatible goods, documents, or practices simply could not enter streamlined systems without incurring delay or rejection. Over time, this filtering effect reshaped incentives across supply chains. Firms aligned upstream processes to meet downstream requirements, even when those requirements originated far from the point of production. Compliance costs became fixed investments rather than recurring negotiations. As a result, trade systems favored actors capable of absorbing these costs at scale. Smaller producers faced pressure to conform or exit, reinforcing consolidation within standardized frameworks. Coordination emerged as an outcome of structural alignment, rather than ongoing agreement. Historically, this process intensified during the expansion of multinational production networks in the 20th century. By the 1920s and 1930s, firms operating across borders required consistent specifications to manage dispersed operations. At the time, vertically integrated corporations standardized components to enable interchangeability across factories. Wartime production accelerated these practices, as governments imposed uniform standards to mobilize industry rapidly. After 1945, these methods migrated into civilian trade, supporting reconstruction and growth. By the 1960s, standardized components and processes underpinned emerging global supply chains. Goods were assembled from parts produced in multiple countries, each adhering to shared specifications. This historical trajectory embeds standardization deeply into the logic of industrial coordination. Documentation became a critical site where standardization shaped coordination most visibly. Trade relied increasingly on standardized forms that represented goods, ownership, risk, and responsibility. Bills of lading, invoices, customs declarations, and insurance certificates functioned as interfaces between physical movement and institutional control. The reason these documents mattered was not their content alone, but their format. This worked because standardized documents could be processed rapidly by multiple parties without reinterpretation. Banks, ports, customs authorities, and insurers relied on predictable layouts and terminology to manage volume. Errors or deviations triggered inspection, delay, or rejection. Over time, documentation standards disciplined behavior by making conformity the path of least resistance. Coordination occurred through paperwork that translated diverse realities into uniform representations. According to economic historians and logistics research, standardized documentation significantly reduced transaction costs while increasing system dependency. Studies show that harmonized customs forms lowered clearance times and administrative expenses across borders. According to trade facilitation analyses, uniform financial instruments enabled faster settlement and reduced disputes. These efficiencies compounded as trade volumes expanded. However, research also indicates that documentation systems introduce new vulnerabilities. Errors propagated quickly when replicated across standardized templates. According to institutional assessments, rigid formats limited the ability to accommodate exceptional circumstances without manual intervention. The same structures that accelerated routine operations slowed response during disruption. Standardization optimized for speed under assumed conditions, embedding fragility alongside efficiency. The spread of standards also altered how power operated within trade systems. Authority shifted from negotiation to rule setting, privileging those who shaped standards over those who merely followed them. The mechanism favored early movers and dominant actors capable of institutional influence. This worked because once standards were established, compliance became mandatory for participation. Firms and states that aligned their practices gained access to markets, while others faced exclusion. Over time, standards reflected the priorities and capabilities of their architects. Technical specifications carried economic consequences, shaping cost structures and competitive advantage. Coordination thus became asymmetric, with influence concentrated upstream in the design of rules rather than downstream in their application. By the late 20th century, digital technologies reinforced these dynamics by embedding standards into software systems. At the time, electronic data interchange replaced paper documents with machine-readable formats. This transition required even stricter standardization, as systems depended on precise compatibility. Once implemented, digital standards automated coordination across organizations. Transactions executed without human intervention, provided inputs matched expected formats. This increased throughput while reducing discretion. Deviations triggered system errors rather than negotiation. According to information systems research, automation amplified both efficiency and brittleness. The architecture of trade increasingly assumed continuous data flow, further constraining adaptability during interruption. Standardization thus transformed coordination into a background condition that shaped trade invisibly, yet decisively. Actors operated within predefined channels that reduced friction while limiting alternatives. Systems functioned smoothly when variation remained within anticipated bounds. When conditions shifted, coordination mechanisms designed for stability struggled to adjust. Uniformity amplified interdependence, binding participants into tightly coupled networks. As global trade advanced, the benefits of standardization remained undeniable, yet its structural consequences accumulated quietly. Coordination was no longer achieved through flexibility, but through adherence, leaving systems synchronized, efficient, and increasingly exposed to shared failure modes. As standardization matured, its effects extended beyond coordination into the deeper dynamics of risk distribution within global trade systems. Uniform rules synchronized behavior across vast networks, aligning timing, formats, and expectations. This alignment reduced local uncertainty, but increased systemic exposure by concentrating activity around shared assumptions. When operations followed identical procedures, deviations no longer remained isolated. The architecture favored coherence over redundancy, treating variation as inefficiency rather than resilience. This orientation reflected the priorities of growth-driven systems optimized for throughput and predictability. Over time, trade networks became less tolerant of irregularity, relying on continuous compliance to maintain flow. Standardization stabilized daily operations while quietly amplifying the consequences of interruption. The mechanism through which this exposure accumulated was structural coupling. Standardized systems linked production, transport, finance, and regulation through tightly aligned processes. This worked because uniform interfaces allowed components to interact seamlessly without adaptation. However, tight coupling reduced buffering capacity between stages. Delays or failures in one segment propagated rapidly to others. Inventories were minimized because standardized schedules assumed reliable replenishment. Financial commitments were synchronized with delivery timelines encoded in contracts. As a result, shocks traveled faster than corrective responses. The very efficiency that standards enabled reduced the slack required to absorb disruption. Coordination became precise but unforgiving, leaving little room for deviation. Historically, this condition became visible during periods of crisis that tested standardized trade systems. By the 1970s, global supply chains dependent on uniform practices encountered stress during energy disruptions. At the time, standardized shipping schedules and fuel-intensive logistics struggled to adapt to sudden scarcity. In subsequent decades, financial crises exposed similar vulnerabilities embedded in standardized credit and payment systems. By the early 21st century, trade networks operated with unprecedented integration. Components crossed borders multiple times, each movement governed by shared specifications. These historical episodes demonstrated that standardization did not fail during crises, but revealed the limits of systems designed for stability rather than adaptation. Documentation and compliance regimes further intensified this exposure by enforcing uniform responses to irregular conditions. Standardized procedures defined acceptable actions even during disruption. The reason this mattered was that deviation required authorization outside routine channels. This worked because compliance systems prioritized consistency over situational judgment. During interruptions, actors followed prescribed steps that often assumed normal conditions. Manual overrides existed, but they were slow and centralized. As a result, localized problems escalated while awaiting approval or clarification. Standardization disciplined response as much as routine operation, shaping how systems behaved under strain. Coordination persisted, but it was rigid, constrained by predefined logic. According to logistics studies and institutional analyses, highly standardized systems exhibit predictable failure patterns. Research shows that disruptions propagate more widely in tightly coupled networks than in loosely coordinated ones. According to supply chain resilience studies, uniform sourcing and specifications increase exposure to shared risks. These findings do not suggest that standardization causes disruption, but that it shapes its impact. Standardized architectures trade local adaptability for global efficiency. According to economic assessments, the benefits dominate during periods of stability but reverse during sustained interruption. The architecture amplifies whatever conditions prevail, rewarding regularity and magnifying disturbance. The concentration of standards also reshaped strategic behavior among states and firms. Control over standard setting became a form of influence within global trade. The mechanism favored those able to define acceptable practices rather than merely comply with them. This worked because standards determined access, cost structures, and compatibility. Governments and corporations invested in shaping technical norms through committees and regulatory forums. These efforts framed coordination as neutral and technical, yet their consequences were distributive. Standards embedded strategic priorities into seemingly objective rules. Over time, influence over architecture mattered as much as capacity to operate within it. Coordination thus became a site of quiet competition rather than overt negotiation. By the late 20th century, debates around flexibility and resilience began to emerge within trade governance. At the time, scholars and policymakers questioned whether standardized systems could adapt to increasing uncertainty. Proposals emphasized modularity, diversification, and redundancy within existing frameworks. However, these measures often conflicted with incentives created by standardization itself. Uniformity rewarded scale and predictability, while resilience required tolerated variation. Attempts to reconcile these priorities remained limited by institutional inertia. Standards evolved incrementally, preserving compatibility while resisting fundamental change. The architecture remained optimized for efficiency, with adaptation treated as exception rather than design principle. Standardization ultimately defined the character of coordination within modern global trade. It transformed alignment from an active process into an embedded condition enforced through systems and rules. This produced unprecedented scale and integration, while concentrating exposure within shared structures. Trade networks became synchronized machines that excelled under expected conditions and struggled when those conditions shifted. The architecture delivered continuity by narrowing choice, stabilizing flow by constraining flexibility. As global trade moved forward, the legacy of standardization endured as both foundation and limitation, shaping systems that were coherent, powerful, and increasingly dependent on the assumption that coordination itself would remain uninterrupted. Industrial mass logistics left global trade powerful yet exposed, efficient yet fragile, and increasingly dependent on coordination rather than territorial expansion alone. As production scaled and movement accelerated, the central challenge shifted toward maintaining alignment across vast networks operating without shared culture, proximity, or continuous negotiation. Standardization emerged as the primary response to this condition, offering stability where flexibility had been lost. Instead of relying on trust or localized convention, trade systems adopted formal rules that reduced interpretive variation across transactions. These rules governed how goods were classified, measured, priced, insured, documented as they moved through interconnected systems. By narrowing acceptable differences, standardization replaced interpersonal judgment with procedural consistency embedded into daily operations. Coordination costs declined as predictability increased, allowing organizations to function across distance with minimal friction. Yet this same process quietly concentrated dependence within uniform structures that assumed normal operation as the default state of exchange. Standardization did not originate as a single reform or coordinated global project, but as a layered accumulation of practices responding to recurring inefficiencies. Merchants, manufacturers, and transport operators repeatedly encountered losses caused by mismatched expectations rather than physical obstacles. Variations in weights, measures, packaging, terminology, and documentation produced delays that compounded as volumes increased. Each inconsistency required resolution, often through negotiation, inspection, or arbitration, consuming time and capital. As trade intensified, these frictions became intolerable at scale. The mechanism was straightforward. Reducing interpretive discretion reduced transactional delay. This worked because uniform inputs allowed processes to be automated, sequenced, and delegated without constant oversight. Over time, informal conventions hardened into codified standards enforced through contracts, institutions, and infrastructure. What began as practical alignment evolved into an architectural feature of global exchange, shaping how systems were designed and operated. By the late 19th century, industrial economies were actively formalizing standards to support expanding trade volumes. Measurement systems were rationalized, with national governments promoting uniform weights and measures to facilitate taxation and commerce. At the time, railways required standardized gauges, schedules, and signaling systems to operate across regions without interruption. Shipping adopted standardized documentation to manage growing cargo complexity, including bills of lading and manifests. Commodity exchanges codified grades and classifications to allow goods to be traded sight unseen. By 1900, industrial trade relied increasingly on paper representations that stood in for physical inspection. These developments reflected a broader shift toward abstraction within trade systems. Goods were no longer valued solely as physical objects, but as standardized units compatible with financial, legal, and logistical processes. This abstraction allowed markets to expand while remaining governable. Standardization also reshaped institutional roles within global trade, redistributing authority away from individual actors towards systems of verification. Inspectors, certifying bodies, and regulatory agencies emerged to enforce compliance with shared specifications. The reason this became necessary was scale, as personal reputation could no longer guarantee reliability across millions of transactions. This worked because third-party validation substituted institutional trust for interpersonal familiarity. Once embedded, standards enabled coordination across firms that never interacted directly. Contracts reference specifications rather than relationships, allowing transactions to proceed without negotiation over basic terms. Over time, compliance became a prerequisite for participation rather than a competitive advantage. Firms organized internal processes to meet external standards, aligning production, packaging, and documentation accordingly. Trade systems became less negotiable but more predictable, emphasizing conformity over adaptation. According to historical trade records and economic studies, the 20th century marked a decisive acceleration in global standardization efforts. International organizations formed to harmonize rules across borders, reducing national variation that impeded commerce. Studies show that standardized container sizes, pallet dimensions, and documentation formats significantly reduced handling costs and transit times. According to shipping industry analyses, uniform containerization alone transformed port operations by enabling mechanized loading and scheduling. Financial standards similarly aligned payment systems, credit instruments, and insurance practices across jurisdictions. These changes reinforced each other, as compatibility in one domain increased returns in others. According to institutional research, standardization generated network effects that rewarded early adoption and penalized deviation. Once established, standards proved difficult to modify, embedding historical decisions into long-term operational structures. The consolidation of standards altered the balance between resilience and efficiency within trade systems. Uniformity allowed processes to be optimized around predictable inputs, reducing redundancy and excess capacity. The mechanism favored throughput over adaptation, as systems assumed continuous flow rather than interruption. This worked because stable conditions allowed specialization to increase productivity across networks. However, the same assumptions limited the ability to respond to unexpected variation. When disruption occurred, standardized systems lacked alternative pathways designed for deviation. Local improvisation was constrained by global requirements that prioritized consistency. As a result, shocks propagated rapidly across interconnected structures. Standardization stabilized daily operation while amplifying systemic exposure during periods of strain. By the mid-20th century, standardization had become inseparable from governance in global trade. National policies increasingly aligned with international norms to maintain access to markets. At the time, regulatory convergence was framed as technical cooperation rather than political integration. Standards organizations expanded their influence by defining acceptable practice across industries. These bodies operated through consensus, yet their outcomes carried binding consequences. Compliance determined participation, while deviation resulted in exclusion or inefficiency. Over time, standards shaped not only how trade occurred, but which actors could compete effectively. Small variations became barriers rather than expressions of local preference. The architecture of trade favored alignment over diversity, reinforcing dominant practices through repetition. Standardization ultimately transformed coordination from an active process into a structural condition, embedded within systems themselves. Trade no longer depended on continuous agreement, but on adherence to predefined forms that assumed mutual recognition. This reduced friction while constraining choice, binding participants into shared operational logic. The system functioned smoothly when assumptions held, delivering scale, speed, and integration across regions. Yet this smoothness masked growing interdependence as deviation became increasingly costly. Uniform standards concentrated risk within tightly coupled networks optimized for regularity. As global trade advanced, coordination ceased to be negotiated and became enforced through architecture, leaving systems powerful, synchronized, and increasingly dependent on conditions remaining within expected bounds. As standards embedded themselves into trade systems, their influence extended beyond technical alignment into the deeper structure of economic coordination. Uniform rules began to shape behavior by defining what was permissible, efficient, and legible within global exchange. Actors adjusted not only to comply, but to optimize within these constraints. Trade schedules, inventory strategies, and investment decisions increasingly assumed standardized inputs and outputs. The architecture of trade became anticipatory, designed around expected conformity, rather than negotiated exception. This shift reduced uncertainty under normal conditions, allowing planning horizons to extend and capital to commit with greater confidence. At the same time, it narrowed the range of viable alternatives when circumstances changed. Coordination was no longer something achieved repeatedly through interaction. It was pre-configured into systems that operated according to shared assumptions. The mechanism through which standards enforced coordination was indirect yet powerful. By defining acceptable forms, standards filtered variation before transactions occurred. This worked because incompatible goods, documents, or practices simply could not enter streamlined systems without incurring delay or rejection. Over time, this filtering effect reshaped incentives across supply chains. Firms aligned upstream processes to meet downstream requirements, even when those requirements originated far from the point of production. Compliance costs became fixed investments rather than recurring negotiations. As a result, trade systems favored actors capable of absorbing these costs at scale. Smaller producers faced pressure to conform or exit, reinforcing consolidation within standardized frameworks. Coordination emerged as an outcome of structural alignment, rather than ongoing agreement. Historically, this process intensified during the expansion of multinational production networks in the 20th century. By the 1920s and 1930s, firms operating across borders required consistent specifications to manage dispersed operations. At the time, vertically integrated corporations standardized components to enable interchangeability across factories. Wartime production accelerated these practices as governments imposed uniform standards to mobilize industry rapidly. After 1945, these methods migrated into civilian trade, supporting reconstruction and growth. By the 1960s, standardized components and processes underpinned emerging global supply chains. Goods were assembled from parts produced in multiple countries, each adhering to shared specifications. This historical trajectory embeds standardization deeply into the logic of industrial coordination. Documentation became a critical site where standardization shaped coordination most visibly. Trade relied increasingly on standardized forms that represented goods, ownership, risk, and responsibility. Bills of lading, invoices, customs declarations, and insurance certificates functioned as interfaces between physical movement and institutional control. The reason these documents mattered was not their content alone, but their format. This worked because standardized documents could be processed rapidly by multiple parties without reinterpretation. Banks, ports, customs authorities, and insurers relied on predictable layouts and terminology to manage volume. Errors or deviations triggered inspection, delay, or rejection. Over time, documentation standards disciplined behavior by making conformity the path of least resistance. Coordination occurred through paperwork that translated diverse realities into uniform representations. According to economic historians and logistics research, standardized documentation significantly reduced transaction costs while increasing system dependency. Studies show that harmonized customs forms lowered clearance times and administrative expenses across borders. According to trade facilitation analyses, uniform financial instruments enabled faster settlement and reduced disputes. These efficiencies compounded as trade volumes expanded. However, research also indicates that documentation systems introduce new vulnerabilities. Errors propagated quickly when replicated across standardized templates. According to institutional assessments, rigid formats limited the ability to accommodate exceptional circumstances without manual intervention. The same structures that accelerated routine operations slowed response during disruption. Standardization optimized for speed under assumed conditions, embedding fragility alongside efficiency. The spread of standards also altered how power operated within trade systems. Authority shifted from negotiation to rule setting, privileging those who shaped standards over those who merely followed them. The mechanism favored early movers and dominant actors capable of institutional influence. This worked because once standards were established, compliance became mandatory for participation. Firms and states that aligned their practices gained access to markets, while others faced exclusion. Over time, standards reflected the priorities and capabilities of their architects. Technical specifications carried economic consequences, shaping cost structures and competitive advantage. Coordination thus became asymmetric, with influence concentrated upstream in the design of rules rather than downstream in their application. By the late 20th century, digital technologies reinforced these dynamics by embedding standards into software systems. At the time, electronic data interchange replaced paper documents with machine-readable formats. This transition required even stricter standardization, as systems depended on precise compatibility. Once implemented, digital standards automated coordination across organizations. Transactions executed without human intervention provided inputs matched expected formats. This increased throughput while reducing discretion. Deviations triggered system errors rather than negotiation. According to information systems research, automation amplified both efficiency and brittleness. The architecture of trade increasingly assumed continuous data flow, further constraining adaptability during interruption. Standardization thus transformed coordination into a background condition that shaped trade invisibly, yet decisively. Actors operated within predefined channels that reduced friction while limiting alternatives. Systems functioned smoothly when variation remained within anticipated bounds. When conditions shifted, coordination mechanisms designed for stability struggled to adjust. Uniformity amplified interdependence, binding participants into tightly coupled networks. As global trade advanced, the benefits of standardization remained undeniable, yet its structural consequences accumulated quietly. Coordination was no longer achieved through flexibility, but through adherence, leaving systems synchronized, efficient, and increasingly exposed to shared failure modes. As standardization matured, its effects extended beyond coordination into the deeper dynamics of risk distribution within global trade systems. Uniform rules synchronized behavior across vast networks, aligning timing, formats, and expectations. This alignment reduced local uncertainty, but increased systemic exposure by concentrating activity around shared assumptions. When operations followed identical procedures, deviations no longer remained isolated. The architecture favored coherence over redundancy, treating variation as inefficiency rather than resilience. This orientation reflected the priorities of growth-driven systems optimized for throughput and predictability. Over time, trade networks became less tolerant of irregularity, relying on continuous compliance to maintain flow. Standardization stabilized daily operations while quietly amplifying the consequences of interruption. The mechanism through which this exposure accumulated was structural coupling. Standardized systems linked production, transport, finance, and regulation through tightly aligned processes. This worked because uniform interfaces allowed components to interact seamlessly without adaptation. However, tight coupling reduced buffering capacity between stages. Delays or failures in one segment propagated rapidly to others. Inventories were minimized because standardized schedules assumed reliable replenishment. Financial commitments were synchronized with delivery timelines encoded in contracts. As a result, shocks traveled faster than corrective responses. The very efficiency that standards enabled reduced the slack required to absorb disruption. Coordination became precise but unforgiving, leaving little room for deviation. Historically, this condition became visible during periods of crisis that tested standardized trade systems. By the 1970s, global supply chains dependent on uniform practices encountered stress during energy disruptions. At the time, standardized shipping schedules and fuel-intensive logistics struggled to adapt to sudden scarcity. In subsequent decades, financial crises exposed similar vulnerabilities embedded in standardized credit and payment systems. By the early 21st century, trade networks operated with unprecedented integration. Components crossed borders multiple times, each movement governed by shared specifications. These historical episodes demonstrated that standardization did not fail during crises, but revealed the limits of systems designed for stability rather than adaptation. Documentation and compliance regimes further intensified this exposure by enforcing uniform responses to irregular conditions. Standardized procedures defined acceptable actions even during disruption. The reason this mattered was that deviation required authorization outside routine channels. This worked because compliance systems prioritized consistency over situational judgment. During interruptions, actors followed prescribed steps that often assumed normal conditions. Manual overrides existed, but they were slow and centralized. As a result, localized problems escalated while awaiting approval or clarification. Standardization disciplined response as much as routine operation, shaping how systems behaved under strain. Coordination persisted, but it was rigid, constrained by predefined logic. According to logistic studies and institutional analyses, highly standardized systems exhibit predictable failure patterns. Research shows that disruptions propagate more widely in tightly coupled networks than in loosely coordinated ones. According to supply chain resilience studies, uniform sourcing and specifications increase exposure to shared risks. These findings do not suggest that standardization causes disruption, but that it shapes its impact. Standardized architectures trade local adaptability for global efficiency. According to economic assessments, the benefits dominate during periods of stability but reverse during sustained interruption. The architecture amplifies whatever conditions prevail, rewarding regularity and magnifying disturbance. The concentration of standards also reshaped strategic behavior among states and firms. Control over standard setting became a form of influence within global trade. The mechanism favored those able to define acceptable practices rather than merely comply with them. This worked because standards determined access, cost structures, and compatibility. Governments and corporations invested in shaping technical norms through committees and regulatory forums. These efforts framed coordination as neutral and technical, yet their consequences were distributive. Standards embedded strategic priorities into seemingly objective rules. Over time, influence over architecture mattered as much as capacity to operate within it. Coordination thus became a site of quiet competition rather than overt negotiation. By the late 20th century, debates around flexibility and resilience began to emerge within trade governance. At the time, scholars and policymakers questioned whether standardized systems could adapt to increasing uncertainty. Proposals emphasized modularity, diversification, and redundancy within existing frameworks. However, these measures often conflicted with incentives created by standardization itself. Uniformity rewarded scale and predictability, while resilience required tolerated variation. Attempts to reconcile these priorities remained limited by institutional inertia. Standards evolved incrementally, preserving compatibility while resisting fundamental change. The architecture remained optimized for efficiency, with adaptation treated as exception rather than design principle. Standardization ultimately defined the character of coordination within modern global trade. It transformed alignment from an active process into an embedded condition enforced through systems and rules. This produced unprecedented scale and integration, while concentrating exposure within shared structures. Trade networks became synchronized machines that excelled under expected conditions and struggled when those conditions shifted. The architecture delivered continuity by narrowing choice, stabilizing flow by constraining flexibility. As global trade moved forward, the legacy of standardization endured as both foundation and limitation, shaping systems that were coherent, powerful, and increasingly dependent on the assumption that coordination itself would remain uninterrupted.
Trade finance organized obligation and timing, but physical exchange still depended on place. As settlements standardized expectation, ports absorbed consequence. They became the points where abstract contracts encountered material limits. Goods arrived with paperwork complete, yet still waited for berths, cranes, labor, and clearance. This tension between financial smoothness and physical constraint defined the modern port. Ports were not neutral gateways, but engineered systems designed to compress uncertainty. Their layout, governance, and technology translated global demand into localized movement. As volumes grew, ports evolved from civic harbors into industrial machines. This shift redirected investment away from vessels alone toward shore-based infrastructure. The architecture of trade expanded laterally, embedding coordination in land as much as in law. Administrative zones, security perimeters, and access corridors segmented activity by risk and function. Each boundary reduced ambiguity while increasing procedural depth. The port thus mirrored settlement systems by privileging predictability over improvisation. Delays were tolerated if they were legible. Bottlenecks were acceptable if they were scheduled. Over time, this logic redefined coastal space as logistical territory rather than urban commons. These transformations marked the starting condition for containerization, globally integrated. Modern ports developed as layered systems rather than singular facilities. Early harbors handled mixed cargo with flexible labor and minimal mechanization. As industrial output increased, this flexibility became inefficiency. Break bulk handling required repeated lifting, sorting, and storage. Damage, theft, and delay scaled with volume. Port authorities responded by reorganizing space into specialized terminals. Warehouses aligned with rail spurs and road access. Cranes replaced muscle where possible, but coordination remained fragmented. Every cargo type demanded distinct equipment and routines. This fragmentation imposed cognitive and administrative load on operators. Scheduling conflicts multiplied as ships grew larger. The result was congestion that infrastructure alone could not resolve. The problem was not capacity, but coordination. Without a unifying handling logic, throughput plateaued despite investment. Labor relations intensified strain as work rules preserved complexity. Informal practices filled gaps left by formal planning. According to port studies from the mid-20th century, turnaround times stagnated despite deeper berths and stronger cranes. The port had become a bottlenecked processor within an expanding system. This condition set limits on trade growth before containerization and exposed structural weaknesses in maritime logistics worldwide during the post-war period. The container introduced a unifying logic to cargo movement. Its mechanism was simplification through standardization. Goods were sealed once and moved intact across modes. Handling shifted from individual items to uniform units. This worked because interfaces became predictable. Cranes, trucks, and ships could be designed around fixed dimensions. Labor shifted from sorting to supervision. Administrative processes followed the box rather than the contents. According to engineering analyses, each eliminated handling step reduced time and error multiplicatively. The container, therefore, acted as an information device as much as a physical one. It encoded ownership, destination, and security into a single object. This reduced negotiation at transfer points. Ports reorganized around flow rather than storage. Space previously used for warehousing became staging ground for rapid exchange. By the late 1960s, this logic had spread unevenly but persistently. Studies show port productivity increased several-fold where container systems matured. The gains were structural rather than incremental, altering the economics of distance and delay. This reconfiguration forced ports to scale landward and outward simultaneously, reshaping coastal infrastructure and investment priorities across regions with lasting implications for trade architecture and institutional governance.
Containerization required ports to rebuild themselves physically. Traditional finger piers proved incompatible with container flow. Flat, expansive terminals became necessary. This favored locations with abundant land and deep water. Older urban ports faced displacement pressures. By 1970, major investments shifted to peripheral sites such as Newark, Felixstowe, and Yokohama. Governments intervened heavily due to scale and cost. Public authorities financed dredging, land reclamation, and access corridors. Private operators supplied equipment and management. At the time, these partnerships were experimental. According to transport records, capital costs exceeded previous port investments by orders of magnitude. The commitment locked regions into specific trade geographies. Once built, terminals resisted relocation. The port became a fixed node anchoring mobile networks. Historical analyses note that labor displacement followed spatial change. Dock communities shrank as automation advanced.
By the 1980s, employment per ton handled had collapsed. These shifts provoked political conflict but rarely reversed investment decisions. The architecture favored continuity over social adjustment. According to economic history studies, sunk costs entrenched container corridors globally, shaping national strategies and regional competitiveness for decades afterward, with effects still evident in contemporary shipping patterns across major trade lanes. Shipping adapted alongside ports through vessel specialization. Container ships sacrificed flexibility for efficiency. Their mechanism relied on scale economies. Larger hulls reduced cost per unit when fully utilized. This worked because standardized boxes simplified stowage. However, scale imposed rigidity. Ships required compatible ports and steady volume. According to shipping studies, utilization rates determined profitability more than speed. Therefore, networks consolidated around predictable routes. Alliances formed to share capacity and stabilize schedules. This coordination reduced competition at the margin. It also increased systemic coupling. A disruption at one node propagated widely. The architecture optimized average performance while amplifying tail risk. Ports adjusted to these requirements by deepening channels and extending berths. Hinterland connections gained strategic importance. Rail and road interfaces determined turnaround time. Studies show inland congestion could negate maritime efficiency gains. The system became only as smooth as its weakest interface. This interdependence narrowed options during shocks and demand swings. According to logistics analyses, resilience declined as throughput concentration increased. Efficiency gains were real, but adaptability remained structurally constrained by design rather than accident within the containerized shipping architecture governing global trade flows through standardized maritime corridors. Port governance evolved to manage intensified capital and coordination demands. Landlord models separated ownership from operation. Public authorities retained land while leasing terminals. This structure aligned long-term planning with private efficiency. By the 1990s, privatization expanded globally. According to World Bank surveys, concession models improved investment speed. They also standardized contractual expectations across countries. At the time, reform was framed as modernization. Labor protections weakened as flexibility increased. Unions lost leverage tied to fixed docks. These changes reduced local veto power over global flows. Ports became interchangeable nodes within networks. Governance shifted from civic accountability to performance metrics. Historical records indicate uneven outcomes across regions. Some ports reinvested gains locally. Others functioned as extractive platforms. Studies showed disparities widened between hub ports and secondary harbors. The architecture rewarded scale and compliance over diversity. According to comparative research, governance convergence reduced experimentation. This stabilized investment climates while narrowing institutional variation. Ports increasingly resembled financial infrastructure in their regulatory logic, predictable, auditable, and oriented toward continuous throughput targets with limited tolerance for disruption or local deviation embedded within global logistics governance regimes that prioritize stability over adaptability system-wide.
Containers also transformed inland geography. Ports extended influence through corridors and dry ports. Rail hubs synchronized with maritime schedules. This reduced coastal congestion while expanding hinterlands. The mechanism relied on time certainty rather than proximity. According to logistics studies, inland terminals functioned as virtual ports. Customs clearance shifted away from waterfronts.
This decoupled trade from coastline density. Regions without ports gained partial access to global flows. However, dependence increased on corridor reliability. A disruption inland could halt maritime exchange. The architecture stretched without becoming flexible. It distributed nodes but centralized control. Trade space expanded while governance tightened. Historical freight data shows traffic concentration along selected axes. Investment followed predictability rather than resilience. According to regional studies, peripheral areas became vulnerable to single corridor failure. The system favored scale replication over adaptive redundancy. This pattern reinforced hierarchical spatial organization within global trade. Ports sat atop networks that extended far beyond their physical boundaries, yet decision authority remained concentrated among few operators, according to Shipping Alliance disclosures and infrastructure contracts. This asymmetry shaped regional development outcomes unevenly over time and across multiple economic cycles within the containerized trade system. By the early 21st century, ports, ships, and containers formed a single operational logic, each component optimized for flow under stable conditions. The reason this architecture persisted was cumulative investment. Infrastructure hardened assumptions into concrete and steel. According to system analyses, changing one layer imposed costs across all others. Adaptation, therefore, occurred slowly and defensively. Efficiency gains masked fragility during normal operation. When shocks appeared, recovery depended on rerouting rather than redesign. The architecture could bend but not reimagine itself. Ports processed record volumes while tolerating minimal deviation. This condition defined the maturity of containerized trade. Its success lay in disciplined repetition. Its limits emerged when repetition failed. According to contemporary logistics reports, capacity utilization approached engineered maxima. Slack was designed out rather than stored. This left little margin for unexpected patterns of demand or disruption. The architecture remained powerful precisely because alternatives were costly. Investment cycles reinforced existing paths, delaying structural change. Ports continued to expand throughput while absorbing risk indirectly through insurance, scheduling buffers, and contractual clauses. These mechanisms preserved continuity under expected variation, but revealed tension when confronted with systemic shocks and cascading disruption. The container system matured alongside digital coordination rather than replacing it. Physical standardization created the conditions for informational consolidation. As cargo units became uniform, tracking and scheduling followed. Ports integrated terminal operating systems to manage yard density, crane allocation, and gate flow. These systems translated movement into data streams. The architecture depended on synchronization across actors with divergent incentives. Shipping lines prioritized vessel utilization. Terminal operators focused on berth productivity. Trucking firms optimized turnaround time. Each actor relied on shared schedules that assumed compliance. This worked because deviations were costly and visible. According to logistics research, information transparency substituted for slack. Ports functioned as real-time processors rather than storage sites. Delays were measured in minutes rather than days. This compression intensified pressure on interfaces. Small disturbances cascaded quickly. The system rewarded discipline and penalized variance. Over time, software embedded assumptions about normal flow. These assumptions shaped behavior and investment. Physical infrastructure followed digital expectation. Cranes were sized to software forecasts. Yard layouts reflected algorithmic priorities. The port became a cyber-physical system optimized for repetition under constrained variance.
The mechanism linking containers and data relied on predictability. Each container carried identifiers that anchored documentation. Bills of lading, manifests, and customs declarations referenced standardized units. This reduced ambiguity in liability and routing. According to customs studies, clearance times fell dramatically where digital pre-filing aligned with container tracking. The system worked because inspection became selective. Risk models filtered cargo flows. Most boxes moved untouched. This amplified throughput while concentrating scrutiny. Ports reorganized space accordingly. Inspection zones shrank relative to flow lanes. According to security analyses, post-2001 regulations expanded data requirements without reversing container logic. Surveillance layered atop existing architecture rather than replacing it. This preserved efficiency while increasing administrative depth. The result was a dense compliance environment that remained invisible to most cargo. Trade appeared seamless because controls were front-loaded and abstracted. The architecture internalized governance within movement. Containers functioned as regulated carriers of permission as well as goods. This dual role deepened reliance on digital coordination. Failure modes shifted from physical breakdown to informational mismatch. Shipping networks consolidated as digital coordination matured. Alliance structures emerged to stabilize schedules and share capacity. According to industry records, the top alliances controlled the majority of container throughput by the 2010s. This concentration reduced redundancy. Ports adapted by courting alliance membership rather than individual lines. Terminal contracts reflected volume guarantees rather than service diversity. The mechanism favored scale matching. Larger ships required fewer calls. Smaller ports lost relevance. According to maritime geography studies, network topology flattened into hub and spoke structures. This reduced total port calls while increasing terminal intensity. Ports expanded vertically through automation rather than horizontally through diversification. Investment targeted quay length and crane reach. The architecture optimized berth productivity metrics. This narrowed acceptable operational profiles. According to performance studies, ports converged in design regardless of regional context. Local variation diminished. Governance frameworks standardized globally. This convergence simplified planning while reducing adaptive capacity. When flows shifted unexpectedly, reconfiguration proved slow. The architecture assumed stable trade lanes and predictable demand. It managed fluctuation through buffers rather than redesign. This reinforced path dependence across shipping and port systems worldwide. Labor relations evolved under automation pressure. Container terminals reduced manual handling dramatically. The remaining roles required technical skill rather than physical endurance. According to labor statistics, employment declined while wages polarized. Skilled operators gained leverage. Casual labor disappeared. Ports negotiated long-term agreements to ensure continuity. These agreements traded employment security for operational flexibility. The architecture favored stability over contestation. Strikes became rare but impactful. According to historical records, labor disruptions exposed systemic fragility precisely because slack was minimal. Ports responded by accelerating automation. This further reduced human mediation. The system internalized conflict resolution through technology rather than negotiation. Governance shifted from social to technical control.
This reduced variability but increased capital intensity. According to economic studies, fixed costs dominated terminal economics. Profitability depended on volume certainty. This reinforced alliance power. Ports became service providers to networks rather than autonomous actors. Their role narrowed to execution within prescribed parameters. The architecture thus aligned labor, capital, and technology around throughput targets. Deviations were treated as faults rather than signals for redesign. Environmental constraints increasingly intersected with port architecture. Container ports concentrated emissions and land use. According to environmental assessments, dredging altered coastal ecosystems. Hinterland corridors intensified pollution inland. The architecture treated these effects as externalities. Mitigation occurred through regulation rather than redesign. Shore power, cleaner fuels, and efficiency gains reduced per-unit impact. Total impact still grew with volume. Ports adopted reporting frameworks to demonstrate compliance. According to sustainability studies, metrics focused on intensity rather than absolute load. This aligned with throughput logic. The system optimized ratios rather than outcomes. Climate risk introduced new uncertainty. Sea level rise threatened fixed infrastructure. According to coastal engineering reports, adaptation costs were high and unevenly distributed. Ports with capital reserves invested in protection, others deferred action. The architecture assumed gradual change rather than abrupt disruption. This assumption mirrored earlier settlement systems. Risk was priced, insured, and delayed. Structural transformation remained unlikely under existing incentive frameworks governing containerized port development globally.
The inland extension of ports intensified coordination demands. Rail schedules synchronized with vessel windows. According to intermodal studies, missed connections propagated delays rapidly. Dry ports absorbed some volatility. They also shifted congestion inland. The architecture relied on corridor reliability. Infrastructure investment targeted choke points rather than network redundancy. According to transport planning records, corridors received disproportionate funding. Alternative routes lagged. This created single points of failure. When disruptions occurred, rerouting capacity proved limited. The system recovered through overtime and backlog clearance rather than structural change. This pattern repeated across regions. According to freight resilience research, recovery time increased with network concentration. Ports acted as amplifiers rather than buffers. Their efficiency depended on continuous flow. Storage was minimized. Inventory shifted to moving assets. This reduced working capital but increased exposure. The architecture externalized risk to shippers and consumers. Trade finance absorbed some volatility. Physical systems absorbed the rest through congestion and delay. Digital platforms further centralized control. Terminal operators integrated with shipping line systems. Data sharing improved forecasting. According to logistics platform studies, visibility increased while autonomy decreased. Smaller actors adapted to dominant standards. Innovation occurred within constrained parameters. New entrants faced high barriers. The architecture rewarded compliance. Deviance incurred exclusion. Ports adopted standardized performance indicators. These metrics shaped investment decisions. According to port governance research, benchmarking drove convergence. Local experimentation declined. The system favored replication of proven designs.
This reduced uncertainty for investors. It also limited adaptation to novel conditions. When demand patterns shifted, response lagged. According to recent analyses, container shortages and congestion reflected systemic rigidity rather than isolated failure. The architecture processed shocks sequentially rather than absorbingly. Recovery depended on time rather than transformation. By the time container trade reached maturity, ports functioned as synchronized processors within a global machine. Their architecture embedded assumptions about volume growth, route stability, and institutional continuity. These assumptions delivered decades of efficiency. They also constrained imagination. According to systems theory analyses, highly optimized systems resist change until failure. Ports accumulated success through repetition. Their strength lay in consistency. Their vulnerability emerged when consistency broke. As trade volumes fluctuated and external pressures mounted, the limits of this architecture became visible. Adaptation occurred through marginal adjustment rather than redesign. The system continued to operate because alternatives remained costly and uncertain. Ports expanded capacity while narrowing tolerance for deviation. This tension shaped the late phase of containerization. It set conditions for future stress without resolving underlying rigidity. The architecture persisted not because it was flexible, but because it was deeply entrenched across physical, institutional, and digital layers of global trade. As container systems reached global saturation, marginal efficiency gains slowed. Ports had already optimized layout, equipment, and scheduling around prevailing volumes. Further improvement depended on precision rather than expansion. This shifted attention toward reliability metrics. Variance reduction became more valuable than raw speed. According to operational studies, predictable turnaround improved network performance more than incremental crane productivity. Ports invested in redundancy at the component level while preserving linear flow at the system level. Backup cranes, spare berths, and contingency labor pools appeared. These measures absorbed routine disruption, but not structural shocks. The architecture treated uncertainty as noise rather than signal. This approach preserved throughput under known conditions. It also narrowed the range of tolerated deviation. Ports increasingly resembled industrial plants with fixed cycles. According to logistics analyses, resilience was engineered locally rather than systemically. This created pockets of robustness within an inflexible whole. When disruptions exceeded design thresholds, recovery depended on external adjustment. Ships queued, cargo waited, time absorbed imbalance. The architecture thus relied on temporal elasticity rather than spatial flexibility. Delay became the primary shock absorber, consistent with earlier settlement systems that masked friction until tolerance was exceeded. Congestion revealed the limits of spatial concentration. Megaports handled disproportionate shares of global trade. According to port statistics, a small number of terminals processed the majority of container volume. This concentration simplified routing but increased exposure. Local incidents had global consequences. Fires, weather events, labor disputes, or technical failures propagated quickly. Ports responded by refining scheduling algorithms. Arrival windows tightened. Penalties increased. According to maritime records, compliance improved while slack disappeared. The system optimized around peak conditions. Off-peak flexibility diminished. This produced brittle equilibrium. When demand surged or shifted unexpectedly, Ports lacked adaptive capacity. The architecture prioritized efficiency under average load rather than resilience under stress. This choice reflected investment incentives. Capital flowed toward assets with predictable utilization. Adaptive infrastructure was harder to monetize. According to economic studies, financial models favored steady throughput over optionality. Ports therefore expanded capacity incrementally while preserving core design assumptions. This reinforced concentration despite rising risk exposure. Containers themselves became sites of optimization. Weight distribution, tracking frequency, and routing logic improved. According to logistics engineering studies, micro-level gains accumulated at scale. Yet these gains depended on stable macro conditions. The mechanism relied on forecast accuracy. When forecasts failed, optimization magnified imbalance. Empty containers accumulated unevenly. According to shipping data, repositioning costs rose sharply during demand swings. Ports lacked space to store surplus. The architecture assumed circulation rather than accumulation. This mirrored just-in-time production logic. Inventory moved continuously. Storage was minimized. When circulation slowed, congestion surged. Ports improvised by stacking higher and delaying departures. These measures reduced immediate pressure while increasing downstream disruption. According to operational analyses, recovery required prolonged normalization. The system did not self-correct quickly. It relied on synchronized adjustment across actors. Coordination lagged due to contractual rigidity. The architecture embedded commitments that resisted rapid change. This characteristic defined mature container systems across regions. Regulatory authorities monitored safety, security, and environmental compliance. According to governance studies, regulation focused on node-level performance. Network-level effects remained diffuse. Responsibility fragmented across jurisdictions. Shipping alliances spanned borders. Ports answered to local authorities. Inland corridors crossed multiple regulatory regimes. This fragmentation limited coordinated response. When disruptions occurred, actors optimized locally. This sometimes worsened global outcomes. According to systems research, lack of central coordination increased recovery time. Attempts to impose control risked slowing routine operation. The architecture favored decentralized execution under shared standards. This balanced efficiency and autonomy under normal conditions. Under stress, it revealed coordination gaps. Regulatory intervention often arrived late. It addressed symptoms rather than structure. The system absorbed pressure through delay and cost rather than redesign. These dynamics reflected deep alignment between institutional arrangements and physical infrastructure. Changing one without the other proved difficult.
Investment cycles reinforced inertia. Port infrastructure required decades to amortize. According to financial records, terminals were planned on 30-year horizons. Design assumptions locked in expectations about vessel size, cargo mix, and trade lanes. Deviating from these assumptions threatened asset value. Ports therefore resisted radical change. Incremental upgrades preserved compatibility. Automation retrofits followed existing layouts. According to infrastructure studies, greenfield innovation lagged behind operational need. New concepts faced integration barriers. The architecture favored compatibility over experimentation. This extended the life of existing systems. It also postponed adaptation. As trade patterns evolved, mismatches accumulated. Ports compensated through operational intensity rather than structural revision.
This increased wear and reduced margin. According to maintenance studies, aging infrastructure required rising upkeep. Capital diverted to preservation rather than transformation. The system continued to function, but at rising cost. These costs remained dispersed across actors and regions. Risk management practices attempted to address exposure without altering architecture. Insurance markets absorbed loss. Contracts allocated liability. According to trade finance research, risk pricing increased without reducing fragility. Ports transferred responsibility downstream. Shippers carried delay risk. Consumers absorbed price volatility. The architecture externalized shock impact. This preserved operational continuity while distributing consequences. Such mechanisms aligned with settlement systems that stabilized flows through abstraction. Physical disruption translated into financial adjustment. This worked under moderate stress. Under extreme conditions, abstraction failed. According to historical analyses, systemic shocks overwhelmed contractual buffers. Ports resumed operation, but confidence eroded. Trust in predictability weakened. The architecture remained intact, but its assumptions were questioned. These moments did not dismantle containerization. They exposed its boundaries. The system persisted because alternatives lacked scale. Adaptation occurred at the margin. Risk models updated. Buffers adjusted slightly. Core structure remained unchanged. Geopolitical pressures added complexity. Trade routes intersected with strategic interests. According to international relations studies, ports became instruments of influence. Investment decisions reflected political alignment. Security considerations affected terminal access. The architecture accommodated these pressures unevenly. Some ports diversified partners. Others deepened dependence. According to shipping analyses, fragmentation increased routing complexity. The system absorbed this through alliance reconfiguration rather than infrastructural change. Containers flowed along adjusted paths. Ports competed for relevance. Investment followed perceived stability. This introduced political risk into logistical calculation. The architecture processed it as another variable. Coordination persisted through standardization. This maintained operational continuity while embedding new dependencies. The system remained global, but less neutral. Ports functioned within layered governance structures that combined commercial logic with strategic constraint. These layers interacted without full integration. As containerized trade entered a phase of constraint rather than expansion, the architecture revealed its character fully. It excelled at repetition. It struggled with transformation. Ports, ships, and containers formed a tightly coupled system optimized for expected flows. According to systems analysis, such systems adapt slowly and fail suddenly. Their strength lies in consistency. Their weakness lies in rigidity. The container architecture delivered unprecedented scale and efficiency. It also narrowed the range of viable alternatives. Change required synchronized investment across layers. This rarely occurred. Instead, adjustment accumulated incrementally. Ports expanded capacity while inheriting vulnerability. Shipping networks optimized utilization while amplifying coupling. Containers simplified handling while centralizing control. These dynamics defined the mature phase of global trade infrastructure. They set the stage for future pressures without resolving underlying tension. The architecture continued to function because it was embedded everywhere.
multinational supply chains emerged not as a deliberate design, but as a structural response to the mature containerized world. Once ports, ships, and containers standardized movement, production itself became mobile. Firms no longer needed to concentrate manufacturing in a single location. Components could be sourced, processed, assembled, and distributed across multiple jurisdictions without disrupting final delivery. This shift altered the architecture of trade from linear routes to layered networks. Value creation fragmented into stages optimized independently. The supply chain became an organizing principle rather than a logistical afterthought. Corporate strategy increasingly revolved around coordination rather than ownership. According to industrial organization theory, firms externalized activities that could be standardized while internalizing coordination and control. This logic reshaped global production. The container did not dictate where goods were made, but it removed the penalty for distance. As transport costs stabilized, differences in labor, regulation, and specialization became decisive. Supply chains stretched across borders not because distance vanished, but because its importance diminished relative to other variables. The result was a distributed architecture bound together by contracts, standards, and information flows rather than geography alone. The mechanism that enabled multinational supply chains was modularity applied to production. Processes were decomposed into discrete tasks that could be performed independently, then recombined through logistics. This works because standardized interfaces reduce dependency between stages. Components move between firms and countries with predictable specifications and tolerances. The mechanism relies on repeatability rather than flexibility. Each node performs a narrow function within a larger system. According to systems engineering principles, modular architectures scale efficiently but resist rapid change. Once established, they reward stability and penalize deviation. Firms optimized each segment for cost, speed, or expertise, assuming continuity elsewhere. Coordination replaced integration as the central managerial challenge. Information systems tracked inventory, schedules, and compliance across continents. Contracts substituted for hierarchy. Risk migrated outward, distributed among suppliers, subcontractors, and logistics providers. This architecture allowed corporations to grow without proportionally increasing internal complexity. It also created dependencies that were invisible under normal conditions. When disruptions occurred, failures propagated along modular seams. The architecture functioned smoothly when assumptions held. When assumptions failed, coordination costs surged rapidly across the entire chain. By the late 20th century, multinational supply chains had become the dominant structure of global manufacturing. By the 1980s, firms in electronics, automotive, and apparel routinely split production across multiple countries. At the time, trade liberalization and deregulation reduced barriers to cross-border coordination. Free trade agreements standardized rules governing tariffs, origin, and compliance. Export processing zones proliferated. According to World Bank data, intermediate goods began to represent a growing share of global trade flows. Finished products increasingly embodied inputs from dozens of jurisdictions. East Asia emerged as a manufacturing hub, while design and branding concentrated in advanced economies. This division reflected comparative advantage shaped by policy, infrastructure, and labor markets. By the 1990s, just-in-time production synchronized factories with shipping schedules. Inventory buffers shrank. Capital efficiency improved. These historical developments transformed trade from an exchange between nations into an exchange within firms and networks. Borders remained legally significant, but operationally secondary within the architecture of supply chains.
Multinational supply chains also reshaped the role of the corporation itself. Firms became coordinators of networks rather than owners of assets.
The reason this structure prevailed lies in transaction cost economics. When transaction costs fall below ownership costs, outsourcing becomes rational. Advances in communication, logistics tracking, and legal standardization lowered coordination costs dramatically. Corporations retained control over design, intellectual property, and brand, while outsourcing production stages. This separation allowed rapid scaling without fixed capital expansion. It also shifted bargaining power. Large firms dictated terms to suppliers embedded within the chain. Suppliers competed for inclusion, accepting thin margins in exchange for volume and stability. According to studies in global value chain analysis, power concentrated at nodes controlling standards and market access. Production became substitutable. Coordination became scarce. The architecture rewarded firms capable of managing complexity rather than producing goods. Over time, this redefinition altered employment patterns, investment flows, and national industrial strategies across the global economy. The informational layer became as critical as physical movement within multinational supply chains. Data synchronized production schedules, shipping capacity, and demand forecasts. This mechanism works because real-time visibility reduces uncertainty. When uncertainty declines, firms can reduce slack and inventory. However, reduced slack increases sensitivity. According to resilience research, tightly coupled systems trade robustness for efficiency. Supply chains optimized for predictability performed poorly under volatility. Information systems assumed stable lead times and reliable compliance. Deviations triggered cascading adjustments. A delay in one node required recalibration across multiple tiers. These adjustments consumed managerial attention and computational resources. The informational architecture amplified both coordination capability and systemic fragility. It enabled unprecedented scale while narrowing tolerance for disruption. Efficiency gains accumulated quietly. Vulnerabilities accumulated silently. The balance between them defined the operational character of multinational supply chains during their expansionary phase. By the early 2000s, multinational supply chains extended deeply into domestic economies. At the time, governments competed to attract nodes within global production networks. Policies focused on infrastructure, labor flexibility, and regulatory predictability. According to OECD analyses, participation in global value chains correlated with export growth and productivity gains. Countries specialized in stages rather than industries. Assembly, component manufacturing, logistics, and services dispersed geographically. This integration blurred distinctions between domestic and foreign production. National statistics struggled to capture value creation accurately. Gross exports overstated domestic contribution. Supply chains crossed borders multiple times before completion. Historical trade models based on bilateral exchange became inadequate. The architecture of global trade shifted from nation-centric flows to network-centric structures. This transformation altered how economic power manifested. Control over standards, platforms, and coordination mattered more than control over territory. Multinational supply chains became the primary carriers of this new logic within the global system. Despite their efficiency, multinational supply chains carried structural tensions inherited from earlier architectures. They depended on stable trade rules, predictable transport, and cooperative governance. These assumptions were embedded rather than enforced. The architecture functioned because it was widely adopted, not because it was resilient. According to systems theory, widely embedded systems resist replacement even when strained. Adjustment occurs through local optimization rather than systemic redesign. Firms diversified suppliers incrementally. Governments adjusted policies selectively. Logistics providers expanded capacity cautiously.
These responses preserved the architecture while increasing complexity. Over time, coordination burdens intensified, margins narrowed, redundancy remained limited. The system continued to deliver scale and cost efficiency. It also accumulated stress along contractual, informational, and political seams. These stresses did not halt trade. They reshaped incentives quietly. The architecture of multinational supply chains entered a phase defined less by expansion than by management of interdependence.
Multinational supply chains did not remain static once established. As networks expanded, second- and third-tier dependencies deepened beyond the visibility of lead firms. Primary suppliers outsourced subcomponents, logistics providers subcontracted capacity. Financial exposure diffused across layers. The architecture evolved into a multi-tiered system in which control diminished with distance from the center. This structure functioned efficiently under stable conditions because each tier optimized locally. However, optimization at one layer often obscured constraints at another. According to supply chain mapping studies, many firms lacked accurate knowledge beyond their first-tier suppliers. Visibility declined rapidly with depth. This mattered because disruptions rarely originated at the top. They emerged in peripheral nodes where oversight was weakest. The system absorbed small shocks through redundancy and substitution. Larger shocks propagated unpredictably. The architecture rewarded scale but limited comprehension. Managers governed through abstractions such as lead times, service levels, and risk scores. These metrics simplified decision-making while masking structural fragility. The supply chain became legible only in aggregate, not in detail, which shaped how risk was perceived and managed. The mechanism by which fragility accumulated was concentration combined with interdependence. Firms reduced supplier bases to gain volume discounts and coordination efficiency. This works because consolidation lowers transaction costs and improves consistency. Over time, critical inputs became sourced from a small number of specialized producers. Geographic clustering reinforced this pattern. Certain regions dominated specific components due to expertise, infrastructure, or policy incentives. According to economic geography research, agglomeration increases productivity but amplifies systemic exposure. When a cluster fails, substitutes are limited. Interdependence magnified impact. Downstream firms depended on upstream continuity. Upstream firms depended on downstream demand. Logistics synchronized flows tightly to minimize inventory. The mechanism produced efficiency through alignment. It also produced brittleness through coupling. A failure in one node constrained options elsewhere. Recovery required coordination across firms with misaligned incentives. The system assumed cooperation without enforcing it. Under stress, that assumption weakened. The system did not collapse immediately. It strained, revealing hidden dependencies embedded within routine operations. Risk management practices adapted to this environment unevenly. Firms focused on probabilistic disruptions such as delays, quality issues, and demand fluctuations. These risks were measurable and insurable. Structural risks such as geopolitical shifts or systemic breakdowns received less attention. The reason lies in incentive structures. Quarterly performance metrics favored cost reduction over resilience investment. According to corporate governance studies, redundancy appeared inefficient under normal conditions. Shareholder pressure reinforced lean configurations. Supply chains optimized for average performance rather than worst-case scenarios. This approach worked because disruptions were historically localized and temporary. When broader shocks occurred, responses were reactive. Firms expedited shipments, shifted production temporarily, or drew down inventories. These measures restored flow without altering architecture.
Over time, crisis response became institutionalized without redesign. The system adapted tactically rather than structurally. This pattern preserved competitiveness while increasing exposure. The architecture remained intact because alternatives were costly and coordination intensive. Resilience was discussed, but efficiency remained dominant in practice. By the 2010s, multinational supply chains had extended into services and digital components. At the time, software, data processing, and customer support followed similar fragmentation logic. Tasks were modularized and distributed globally. According to trade in services data, cross-border service flows grew faster than goods trade. This expansion blurred boundaries between manufacturing and services. Physical products depended on digital inputs. Production schedules depended on data integrity. Cybersecurity became a supply chain concern. This integration increased productivity and coordination speed. It also introduced new vulnerabilities. Digital platforms centralized control while distributing execution. Failures propagated rapidly through shared systems. The historical separation between logistics risk and information risk eroded. Multinational supply chains became socio-technical systems, requiring governance across domains. This evolution expanded the scope of trade architecture beyond ports and factories into networks of code, contracts, and compliance regimes.
Labor dynamics within multinational supply chains reflected this structural shift. Production dispersed to regions with cost advantages and flexible labor markets. Employment became fragmented across firms and jurisdictions. According to labor economics research, bargaining power shifted away from workers toward coordinating firms. Suppliers operated under margin pressure, limiting wage growth and investment in workforce stability. Lead firms captured value through design, branding, and market access. This distribution was not accidental. It emerged from architectural position. Nodes controlling standards and demand exerted leverage over interchangeable production nodes. Labor conditions varied widely across the chain. Visibility into these conditions remained limited. Auditing regimes focused on compliance rather than capability building. The architecture externalized social risk alongside operational risk. When disruptions occurred, labor absorbed much of the adjustment through layoffs or informal arrangements. These dynamics sustained low-cost production while embedding social fragility. They also influenced political responses to globalization as outcomes diverged across regions. Governance of multinational supply chains relied heavily on private standards rather than public enforcement. Firms developed codes of conduct, quality certifications, and logistics protocols. The mechanism works because private standards travel faster than regulation. They adapt to operational needs and enforce compliance through contracts. According to institutional analysis, this privatization of governance reduced friction while limiting accountability. Enforcement depended on commercial leverage rather than legal obligation. When incentives aligned, standards improved coordination and performance. When incentives diverged, enforcement weakened. Governments retained authority over borders, but ceded influence over internal chain dynamics. Trade agreements addressed tariffs and market access, not operational architecture. This division created gaps in oversight. Systemic risks fell between jurisdictions and firms. No single actor possessed authority or incentive to redesign the system. Governance remained fragmented, mirroring the architecture itself. Stability depended on alignment rather than control. As interdependence intensified, time became a critical variable. Supply chains compressed lead times to respond to demand signals. Speed increased turnover and reduced working capital. According to operations research, shorter cycles improve responsiveness but reduce buffers. Time compression amplified sensitivity to delay. A missed shipment or production halt cascaded quickly. Firms invested in forecasting and analytics to compensate. These tools extended visibility but could not eliminate uncertainty. Forecasts relied on historical patterns. When patterns shifted, accuracy declined. The architecture assumed continuity of past relationships. When novelty emerged, adjustment lagged. Time-based optimization delivered competitive advantage under stable conditions. It also narrowed margins for error. Multinational supply chains operated closer to their limits. This proximity increased performance while reducing slack. The system functioned as long as disturbances remained within expected ranges. Beyond that, coordination costs escalated rapidly. These characteristics defined the mature phase of multinational supply chains. They delivered efficiency, scale, and specialization across borders. They also embedded concentration, opacity, and tight coupling. The architecture did not fail outright. It persisted through incremental adaptation. Firms layered contingency plans onto existing structures. Governments monitored exposure without restructuring incentives. Logistics providers diversified routes selectively. These measures mitigated symptoms without addressing route architecture. The system remained globally integrated because alternatives were fragmented and costly. Its continued operation depended on widespread participation. As pressures accumulated, the architecture revealed its constraints more clearly. It continued to move goods and value across borders. It also carried forward unresolved tensions that would shape how global trade systems responded to the next phase of stress and reconfiguration.
As multinational supply chains matured, stress increasingly originated outside the commercial domain. Political, environmental, and social factors began interacting directly with production networks. Trade policy shifted from liberalization toward strategic intervention. Environmental constraints affected resource availability and transport reliability. Public scrutiny intensified around labor practices and emissions. These forces did not target supply chains deliberately, but supply chains absorbed their effects because of their embeddedness. The architecture had been built to optimize economic variables under assumed stability. When assumptions changed, adjustment proved uneven. According to political economy analysis, global production networks are sensitive to policy uncertainty because coordination spans jurisdictions. A regulatory change in one country altered cost structures across the chain. Firms responded by reallocating production incrementally rather than redesigning networks. This preserved continuity while increasing complexity. Supply chains became more geographically dispersed, but not less interdependent. Risk spread laterally rather than diminishing. The system adapted by adding layers rather than simplifying. These adaptations extended functionality but also deepened managerial burden. The architecture continued to operate but under growing cognitive and administrative strain. The mechanism by which geopolitical risk entered supply chains involved alignment between production and national strategy. Governments reassessed dependence on foreign suppliers for critical goods. This works because supply chains concentrate capabilities geographically. When a region dominates production, access becomes strategic. According to security studies, economic interdependence can deter conflict or become leverage. Firms found themselves navigating competing policy priorities. Compliance with one jurisdiction risked restriction in another. The architecture offered limited flexibility because specialization had accumulated over decades. Relocating production required capital, time, and skilled labor.
Firms responded by diversifying marginally, creating parallel suppliers or alternative routes. These measures reduced exposure without dismantling existing networks. The result was duplication layered onto concentration. Efficiency declined slightly, resilience improved unevenly. The system remained vulnerable to synchronized shocks. Geopolitical risk did not replace economic logic, it constrained it, altering trade-offs within the existing architecture. Environmental pressures further complicated multinational supply chains. Climate variability disrupted transport and production predictability. Extreme weather affected ports, factories, and logistics corridors. According to climate impact studies, supply chains are particularly exposed to localized environmental events because of concentration. Flooding in one region halted production globally. Firms incorporated environmental risk into planning models. Insurance costs rose. Contingency inventories increased selectively. These responses treated climate as an operational variable rather than a structural constraint. The architecture remained energy-intensive and geographically dispersed. Environmental compliance varied across jurisdictions. Lead firms imposed sustainability standards through contracts. Enforcement depended on audits and reporting. According to sustainability research, such mechanisms improved transparency but struggled to change incentives deeply. Environmental risk accumulated alongside economic and political risk. The system absorbed shocks episodically. Long-term adaptation lagged behind exposure growth. The architecture continued to prioritize throughput over transformation. Technological change offered both mitigation and amplification of these pressures. Automation reduced reliance on labor in some stages, altering location incentives. Advanced analytics improved forecasting and visibility. Digital platforms integrated suppliers more tightly. This works because information substitutes for proximity. Firms could coordinate complex operations remotely. However, technology also increased dependency on shared systems. Cyber risk emerged as a supply chain threat. An outage could halt production across continents. According to cybersecurity assessments, supply chains became vectors for systemic digital risk. Smaller suppliers often lacked robust defenses. Lead firms depended on their weakest links. Technological integration improved efficiency and control. It also concentrated vulnerability within platforms and data flows. The architecture became faster and more precise. It also became more brittle to novel disruptions. Technology extended the reach of multinational supply chains while compressing margins for error further.
Financial structures within supply chains reflected these dynamics. Payment terms lengthened as lead firms shifted working capital burdens onto suppliers. Inventory financing moved off balance sheets. According to financial studies, supply chains functioned as credit networks. Smaller firms financed operations through delayed payments and trade credit. This structure improved cash flow for coordinators while increasing fragility downstream. When disruptions occurred, liquidity stress propagated quickly. Suppliers lacked buffers. Bank financing tightened under uncertainty. Governments intervened selectively to stabilize critical nodes. These interventions addressed symptoms rather than architecture. Financial fragility remained embedded within contractual arrangements. The system relied on continuous flow to sustain solvency. Interruptions threatened not only production but firm survival. Financial interdependence amplified operational risk. The architecture linked material, informational, and financial flows tightly together. By the late 2010s, multinational supply chains had become objects of explicit policy debate. At the time, terms like resilience, diversification, and strategic autonomy entered official discourse. According to policy analysis, governments sought to influence supply chains without dismantling them.
Incentives targeted relocation of specific stages rather than wholesale restructuring. Firms evaluated trade-offs between cost, risk, and compliance. Many adopted hybrid strategies. Core production remained global, peripheral stages localized or duplicated. This approach preserved scale while signaling adaptation. The architecture shifted at the margins. Structural dependencies persisted. Global integration slowed but did not reverse. Supply chains remained the dominant form of organizing production. They absorbed policy pressure by redistributing rather than retreating. This pattern reinforced complexity. Coordination burdens increased. The system continued to function through negotiated adjustment rather than redesign. These adaptations altered how value was measured and managed. Firms invested more in mapping and monitoring. Risk metrics expanded beyond cost and time. According to management research, visibility became a competitive capability. Firms that understood their networks deeply could respond faster. However, visibility did not equate to control. Many dependencies lay beyond contractual reach. Information revealed constraints without resolving them. Decision-makers faced trade-offs between resilience and competitiveness. The architecture offered no neutral option. Any change shifted exposure elsewhere. Supply chains became arenas where economic efficiency, political strategy, and social expectations intersected. This intersection increased decision complexity. It also slowed transformation. Incremental change remained dominant because coordinated change was costly and uncertain. As multinational supply chains entered this phase, their defining feature became persistence under pressure. They did not collapse despite accumulating stress. They adjusted unevenly, preserving core structures. This persistence stemmed from deep embedding across firms, regions, and institutions. According to systems theory, such architectures resist rapid transformation because dependencies are mutual. Change requires synchronized action across layers. Absent coordination, adaptation remains partial. Multinational supply chains continued to move goods, capital, and information across borders. They also carried unresolved tensions forward. These tensions reshaped expectations around reliability, sovereignty, and sustainability. The architecture remained operational because it was indispensable. Its future evolution would be shaped not by expansion alone, but by how systems designed for efficiency negotiated constraint, uncertainty, and the growing demand for structural change across the global trade system.
Global trade did not persist solely because firms moved goods efficiently across borders. Its continuity depended on institutions that stabilized expectations, resolved disputes, and enforced rules across jurisdictions. As multinational supply chains accumulated scale and complexity, informal coordination became insufficient. Contracts required recognition beyond national courts. Standards required acceptance across markets. Payments required trusted settlement mechanisms. Institutions emerged to perform these functions not as neutral observers, but as active components of trade architecture. They shaped incentives, constrained behavior, and translated political agreements into operational rules. The system relied on predictability more than flexibility. Firms invested capital based on assumptions about tariffs, enforcement, and access. These assumptions were upheld through institutional continuity rather than market forces alone. Over time, governance structures became embedded within daily trade operations. They were not external regulators, but internal stabilizers. Their presence reduced uncertainty enough to allow long planning horizons. Trade expanded within these boundaries because the boundaries themselves were stable. When shocks occurred, institutions absorbed part of the disruption by preserving rule continuity. This buffering function became central as supply chains crossed legal, cultural, and monetary systems simultaneously. Governance did not eliminate conflict, but it structured how conflict unfolded. The mechanism by which trade institutions govern lies in rule codification and repetition. Rules gain authority not through force, but through consistent application over time. The reason this works is that firms adapt behavior to minimize friction under known constraints. Tariff schedules, customs procedures, and dispute mechanisms reduce ambiguity about outcomes. This predictability lowers transaction costs more effectively than bilateral trust alone. Institutions transform political agreements into operational routines. Once routines are established, deviation becomes costly. Firms reorganize logistics, sourcing, and compliance systems around them. The architecture becomes path-dependent. Enforcement rarely requires constant intervention because most actors self-regulate to remain compliant. This creates a feedback loop where institutional rules shape behavior and behavior reinforces institutional relevance. Governance thus operates indirectly through incentives rather than commands. According to institutional economics, stability emerges when rule compliance becomes rational for participants. The system does not rely on universal agreement, only broad acceptance. Conflicts are managed within predefined channels. Outcomes may be imperfect, but they are bounded. This boundedness allows trade to continue even amid political disagreement. The architecture favors continuity over optimality. Historically, formal trade institutions expanded alongside the growth of global commerce after the Second World War. By 1947, the General Agreement on Tariffs and Trade established a multilateral framework for reducing trade barriers. At the time, reconstruction and scarcity shaped priorities. States sought predictability to encourage investment and recovery. Over successive negotiation rounds, rules deepened and expanded. In 1995, the World Trade Organization replaced GATT, adding dispute settlement with binding outcomes. This marked a shift from voluntary coordination to institutional enforcement. Parallel bodies emerged to govern finance, shipping, and standards. The International Monetary Fund stabilized currency relations. The World Bank financed infrastructure tied to trade expansion. Standards organizations harmonized technical requirements. Together, these institutions formed an interlocking governance layer. They did not eliminate national sovereignty, but constrained its unilateral use. According to historical records, trade growth correlated with institutional density rather than tariff levels alone. Governance capacity mattered as much as market access. Institutions provided continuity across political cycles. They allowed trade systems to persist even as governments changed.
According to studies by the World Bank and OECD, institutional quality directly affects trade resilience. Countries with transparent customs procedures experience lower volatility during shocks. Research shows that dispute settlement reduces retaliatory escalation. These findings support the view that institutions function as shock absorbers. They slow down destabilizing feedback loops. According to WTO case data, most disputes are resolved without sanctions. The process itself disciplines behavior. Studies also show that firms factor institutional reliability into location decisions. Investment flows align with governance credibility. Even informal expectations about rule stability influence supply chain design. According to comparative analyses, fragmentation increases when institutional trust erodes. Firms compensate by duplicating suppliers or regionalizing operations. Governance gaps thus translate into higher costs. Citation evidence consistently links rule predictability to trade volume stability. These effects accumulate over time. Institutions do not generate growth independently, but they preserve conditions under which growth can occur. Their impact is structural rather than immediate. The data emphasizes continuity, not optimization. Governance sustains motion rather than accelerating it. This subtle role is often overlooked because it operates in the background. As trade systems expanded, institutions increasingly governed interactions between states and firms simultaneously. Rules were no longer confined to border measures. They extended into intellectual property, investment protections, and services. This expansion reflected the changing composition of trade. Value moved through contracts, data, and standards as much as physical goods. Institutions adapted by formalizing complex domains. The mechanism involved translating abstract principles into enforceable procedures. The reason this mattered was that supply chains relied on shared coordination. Without shared rules, fragmentation would increase. Governance provided a common operating language. This language reduced misalignment across jurisdictions. Over time, compliance systems within firms mirrored institutional requirements. Legal, accounting, and logistics departments internalized governance norms. Institutions thus shaped corporate structure indirectly. The architecture became recursive. Firms shaped rules through lobbying and participation, while rules shaped firms through compliance costs. This mutual shaping stabilized the system. It also entrenched existing power distributions. Governance favored actors capable of navigating complexity. Smaller participants adapted by aligning with dominant standards. The system rewarded conformity over experimentation. This preserved scale but reduced flexibility. Trade continued, but within narrower corridors. Historically, moments of institutional strain coincided with geopolitical shifts. By the late 20th century, emerging economies sought greater influence within trade governance. At the time, institutional rules reflected post-war power balances. Negotiations became more complex as membership expanded. Consensus slowed. Enforcement faced political resistance. Despite this, institutions persisted. Their survival reflected dependence rather than legitimacy alone. Supply chains had grown around their frameworks. According to historical accounts, attempts to bypass institutions produced uncertainty. Regional agreements proliferated, but often mirrored multilateral rules. The architecture resisted fragmentation. Even when compliance weakened, reference points remained. Disputes continued to be framed in institutional terms. This demonstrated embedded authority. Institutions endured because alternatives were costlier. Governance inertia set in. Change required coordination across many actors with conflicting interests. This difficulty reinforced stability. Trade institutions thus evolved incrementally rather than through redesign. Their form reflected accumulated compromises. The system remained functional, though strained. Governance became less about expansion and more about maintenance. Institutions managed decline in consensus without collapse in operation.
By the early 21st century, institutions faced new pressures from supply chain complexity and political fragmentation. Digital trade blurred jurisdictional boundaries. Environmental and labor concerns demanded integration into trade rules. Institutions responded unevenly. Some adapted through new agreements and standards. Others lagged behind operational realities. According to institutional theory, adaptation occurs when misalignment threatens core functions. Governance systems began prioritizing dispute management over rule expansion. Stability took precedence over ambition. Firms adjusted expectations accordingly. Trade continued under imperfect rules because predictability still existed. The architecture relied on institutional persistence more than coherence. This persistence carried tensions forward rather than resolving them. Governance became a site of negotiation rather than authority. Yet the system remained operational. Institutions still structured behavior even when contested. Their role shifted from directive to mediating. This mediation preserved continuity under strain. As global trade entered an era of constraint, institutions did not disappear. They absorbed pressure by narrowing scope and slowing change. The architecture held because governance, though imperfect, remained indispensable. Trade institutions did not operate as a single unified authority. They functioned as layered systems with overlapping mandates, jurisdictions, and enforcement capacities. This layering reflected historical accumulation of agreements rather than deliberate design. Customs authorities, standards bodies, financial regulators, and dispute panels each governed specific dimensions of exchange. Their coordination emerged through practice, not central planning. Firms navigated this landscape by aligning operations with multiple rule sets simultaneously. The architecture favored actors capable of managing institutional complexity. Compliance became a form of capability. Over time, governance density increased. More rules addressed more contingencies. This expansion reduced ambiguity but increased administrative burden. Institutions thus shaped trade not only through permission but through cost. Participation required resources devoted to monitoring, reporting, and adaptation. These costs influenced market structure. Large firms absorbed them internally. Smaller firms relied on intermediaries. Governance indirectly encouraged consolidation. Trade systems grew more predictable but less accessible. The institutional environment filtered participation. This filtering stabilized flows by reducing variance in behavior. Governance did not seek efficiency alone. It sought manageability. The system prioritized order over inclusiveness. This trade-off became embedded in the architecture. The mechanism through which layered governance maintains coherence lies in jurisdictional segmentation. Each institution governs a defined domain with limited scope. The reason this works is that complexity is decomposed into manageable units. Customs authorities focus on border procedures. Standards bodies regulate product compatibility. Financial institutions oversee settlement and liquidity. Dispute mechanisms arbitrate conflicts when boundaries are crossed. Coordination occurs through reference rather than command. Institutions cite each other's rules. Firms align compliance systems accordingly. This modularity allows partial adaptation without systemic redesign. When one layer changes, others adjust incrementally. Governance thus evolves through small calibrations. According to systems theory, modular architectures resist collapse because failure is localized. Trade institutions applied this logic unintentionally. Their fragmentation reduced the risk of total breakdown. However, it also obscured accountability. Authority was dispersed. Responsibility became diffuse. Firms responded by standardizing internal processes across jurisdictions. Corporate governance mirrored institutional fragmentation. This alignment reduced friction. The system functioned through mutual accommodation rather than hierarchy. Governance coherence emerged from repetition, not integration. This produced stability under strain. Historically, the proliferation of trade-related institutions accelerated during periods of technological change. By the late 20th century, containerization, digital documentation, and financial globalization expanded transaction velocity. At the time, existing rules proved insufficient. New institutions emerged to govern data flows,
intellectual property and services. The Agreement on Trade-Related Aspects of Intellectual Property Rights formalized protections across borders. Standards organizations expanded technical committees. Financial regulators coordinated settlement systems. These developments reflected functional necessity. Trade outpaced governance, then governance caught up. According to historical analyses, institutional growth followed operational innovation. Rules lagged practice, but eventually codified it. This lag created temporary ambiguity. Firms exploited gaps until standards emerged. Once established, rules hardened. The architecture accumulated layers rather than replacing them. Legacy institutions remained active. New ones added specialization. This produced institutional density. Trade systems became resilient through redundancy. Multiple bodies governed similar issues from different angles. This redundancy reduced reliance on any single authority. It also increased complexity. Governance became cumulative rather than streamlined.
According to comparative studies by international economic organizations, institutional overlap correlates with trade persistence rather than efficiency. Research shows that overlapping mandates reduce volatility during disputes. When one forum stalls, another absorbs pressure. Dispute data indicates that firms prefer negotiated settlements over formal rulings. Institutions facilitate this by providing reference frameworks. According to empirical analyses, most trade conflicts de-escalate before reaching sanctions. The existence of rules shapes expectations even when unenforced. Studies also show that compliance costs rise with institutional density. Firms respond by standardizing processes globally. This standardization reinforces institutional relevance. Data suggests that trade networks with higher governance density recover faster from shocks. The effect is gradual rather than immediate. Institutions do not prevent disruption, but they structure recovery. According to longitudinal data, rule continuity matters more than rule precision. Predictable ambiguity outperforms volatile clarity. These findings support the view that governance sustains motion rather than optimizing outcomes. Institutions function as stabilizers, not engines. Their impact accumulates through time. As governance expanded, informal norms coexisted with formal rules. Trust networks, industry practices, and reputational mechanisms filled gaps. Institutions recognized these norms implicitly. The mechanism involved selective enforcement. Authorities prioritized systemic risks over minor deviations. The reason this mattered was scale. Policing every infraction was impractical. Governance operated through thresholds. Firms learned acceptable variance. This tacit understanding reduced friction. Over time, informal practices became semi-formal standards. Institutions codified what already worked. This process reinforced continuity. Governance followed practice as much as it directed it. The architecture relied on mutual recognition. States recognized foreign certifications. Firms accepted standardized documentation. These recognitions reduced duplication. They also required trust in institutional counterparts. When trust eroded, duplication increased. Governance thus depended on relational stability. Institutions were embedded in networks of expectation. Their authority derived from predictability rather than force. This relational aspect sustained trade under political disagreement. Even when rhetoric escalated, operational routines persisted. The system functioned through habituation. Governance became invisible through repetition. Historically, periods of crisis revealed the limits of institutional coordination. Financial shocks, trade wars, and pandemics stressed governance frameworks. At these moments, institutional rules were tested. By the early 21st century, emergency measures proliferated. Export controls, subsidies, and exceptions strained multilateral norms. Institutions responded unevenly. Some issued guidance, others deferred to national discretion. Despite this, core procedures remained intact. Customs continued operating, settlement systems cleared payments, dispute mechanisms recorded cases. According to historical records, institutions rarely suspended operations entirely. They absorbed shocks by narrowing scope. Governance shifted from liberalization to damage control. This adaptive contraction preserved core functions. Trade volumes fluctuated, but systems endured. Institutions demonstrated endurance through restraint rather than expansion. They did not resolve underlying tensions, they managed their expression. This management prevented cascading failure. Governance thus revealed its primary function: containment. Institutions limited the spread of disruption across layers. This containment sustained the architecture under stress. As trade systems matured, institutions increasingly mediated between economic efficiency and political constraint. Environmental standards, labor provisions, and security concerns entered governance frameworks. This integration reflected changing priorities. The mechanism involved conditional access. Compliance became linked to broader objectives. The reason this mattered was legitimacy. Trade governance required public justification. Institutions adapted by incorporating non-economic criteria. This expanded their mandate. It also complicated enforcement. Balancing objectives required discretion. Governance became interpretive rather than mechanical. Firms adjusted by expanding compliance functions. Trade decisions incorporated political risk. Institutions did not eliminate tension between openness and control. They formalized it. The architecture became a negotiation space. Rules structured debate rather than dictating outcomes. This shift altered expectations. Stability no longer meant predictability alone. It included adaptability. Institutions preserved continuity by accommodating contestation. Governance accepted friction as normal. Trade persisted within contested frameworks. The system remained operational because institutions evolved from rulemakers into managers of disagreement. This role would shape how global trade navigated the constraints ahead.
Institutions governing global trade increasingly operated under conditions of contested legitimacy. Their authority was no longer assumed as neutral or technocratic. Political actors questioned rules perceived as asymmetrical. Firms faced diverging regulatory expectations across markets. Governance became less about rule expansion and more about rule justification. This shift altered institutional behavior. Decision-making slowed. Consensus thresholds rose. The architecture adapted by prioritizing continuity of core functions over normative alignment. Trade flows depended on clearance, settlement, and dispute containment. Institutions concentrated resources on these essentials. Peripheral objectives received uneven attention. This reorientation reflected dependency. Supply chains required baseline governance to function. Even critics relied on institutional procedures when disruptions occurred. Governance thus persisted through necessity rather than agreement. The system tolerated ambiguity in principles as long as operations continued. Institutions absorbed political disagreement by narrowing claims. Authority became procedural rather than moral. This procedural focus preserved predictability under dispute. Trade systems relied on the fact that rules existed, not that they were universally endorsed. This distinction shaped late-stage institutional evolution. The mechanism enabling institutions to function amid contestation lies in procedural inertia. Once routines are established, deviation introduces cost and uncertainty. The reason this works is that trade actors optimize for continuity. Firms align schedules, contracts, and financing around expected procedures. Altering these procedures requires coordination across many participants. Institutions leverage this dependency. They maintain relevance by preserving processes even when rules are debated. Dispute mechanisms continue accepting cases. Standards bodies continue issuing revisions. Settlement systems continue clearing transactions. Governance thus operates through momentum. Change occurs at the margins rather than the core. According to organizational theory, systems with high switching costs resist abrupt transformation. Trade institutions exemplify this dynamic. Their authority is reinforced by the impracticality of alternatives. Parallel systems are costly to build. Fragmentation introduces risk. Institutions remain default coordinators. This default status stabilizes expectations. Even partial compliance sustains coherence. Governance does not require unanimity, it requires sufficient participation. The architecture tolerates dissent as long as exit remains limited. Institutions thus govern through persistence rather than persuasion. Historically, late 20th and early 21st century trade governance reflected this shift toward procedural dominance. By the 2000s, multilateral negotiations stalled while operational activity continued. At the time, institutions redirected focus to implementation and monitoring. Dispute caseloads increased even as rulemaking slowed. This divergence highlighted institutional adaptation. According to historical records, governance shifted from expansion to administration. Regional and bilateral agreements proliferated, but they often referenced multilateral standards. Institutions remained central reference points. Their texts framed negotiations even when outcomes differed. This demonstrated structural embeddedness. Trade architecture relied on institutional memory. Past agreements constrained future options. Governance accumulated layers of precedent. These precedents guided behavior even without active enforcement. Historical analysis shows that institutional endurance correlated with procedural continuity. Institutions survived periods of political paralysis by maintaining operational functions. Trade did not stop, it rerouted through existing frameworks. Governance became quieter but no less consequential. Institutions shaped outcomes by defining what remained possible. According to empirical studies on institutional resilience, continuity of process matters more than breadth of mandate. Research indicates that trade systems recover faster when clearance and settlement remain uninterrupted. Data from past disruptions shows that uncertainty spikes when procedures change suddenly. Institutions mitigate this by preserving familiar routines. According to analyses of dispute resolution, even weakened enforcement influences behavior through expectation management. Firms adjust strategies based on likely outcomes. The existence of a forum shapes negotiation dynamics. Studies also show that fragmented governance increases coordination costs. Institutions reduce these costs by serving as focal points. Citation evidence supports the view that governance effectiveness is cumulative. Small procedural decisions compound over time. Institutions influence trade through repetition rather than intervention. Their impact is diffuse but durable. Quantitative assessments link institutional stability to lower long-term volatility. These findings reinforce the architectural perspective. Governance sustains structure rather than directing flow. Institutions act as load-bearing components. They do not accelerate movement, but they prevent collapse. This stabilizing role becomes most visible under stress.
As global trade faced structural constraints, institutions increasingly mediated trade-offs rather than enforcing optimization. Security concerns intersected with efficiency. Sustainability goals conflicted with cost minimization. Governance frameworks incorporated exceptions, safeguards, and review clauses. The mechanism involved conditional flexibility. Rules allowed deviation under defined circumstances. The reason this mattered was adaptability. Institutions preserved relevance by accommodating constraint. Absolute rules would have encouraged exit. Flexible rules retained participation. This adaptability altered the architecture. Governance became a balancing act. Institutions weighed competing priorities without resolving them fully. Firms adapted by internalizing uncertainty. Compliance strategies incorporated scenario planning. Trade systems adjusted expectations downward while preserving continuity. Institutions thus managed decline in consensus without structural failure. They formalized tension rather than eliminating it. This approach preserved the system's core. Governance shifted from rule enforcement to tension management. The architecture functioned because institutions provided a shared space for negotiation. Even unresolved issues remained contained within procedural boundaries. Trade persisted within these negotiated limits. Historically, institutional adaptation followed crises rather than anticipation. By observing responses to disruptions, institutions recalibrated scope. At the time of major shocks, emergency measures tested flexibility. Some rules were suspended temporarily, others were reinterpreted. Afterward, precedents remained. Governance learned through stress. According to historical accounts, institutions incorporated lessons incrementally. Radical reform remained rare. The architecture favored accretion over redesign. This incrementalism reduced risk. Sudden change threatened coordination. Institutions prioritized survivability. They accepted inefficiencies to maintain alignment. Over time, governance frameworks reflected accumulated compromises. Trade institutions embodied historical memory. Their rules encoded past crises. This memory constrained future action. It also provided reference during uncertainty. Institutions functioned as repositories of experience. Trade systems relied on this accumulated knowledge. Governance reduced the need to relearn coordination under pressure. The architecture endured because institutions remembered how to function amid constraint. This historical continuity reinforced structural persistence. As global trade entered an era defined by constraint, institutions remained central to its navigation. They did not resolve underlying tensions, they structured how those tensions unfolded. Governance preserved continuity by limiting volatility. The architecture relied on institutions to contain disagreement, manage adaptation, and preserve procedural memory. Trade systems no longer expanded through liberalization alone. They persisted through managed adjustment. Institutions became custodians of continuity rather than architects of growth. Their role was understated but decisive. By maintaining shared procedures, they enabled trade to continue amid fragmentation. The system moved forward without consensus, carried by routines established over decades. Governance provided the frame within which change occurred incrementally. The future of global trade would not be shaped by markets alone. It would be shaped by how institutions designed for stability managed pressure, negotiated legitimacy, and preserved coordination in a system where continuity itself had become the primary objective.